Hello. It is time. Okay. All right. So I have a thing with the legs, which I'll find out like what's really going on. I have an idea of what's going on. But that's after I get anti-gravity put in there, which should just be simple. If it's like I'll be able to apply, each leg can apply up to 1/3 of anti-gravity force. Hey Yulia. Or it not exactly 1/3. It'll be math where half the legs are sufficient. So if I had like 10 legs total, 5 legs would be enough, but then 4 legs would be like 4/5 of gravity, 3 legs would be 3/5 of gravity, that kind of thing. Hello world. All right. What do I have? Did I? All right, I noticed some things when I was like looking at it for a second off stream, but I turned off debug because I don't really think I needed it. Okay. So yeah, anti-gravity should just be I think probably after integrate forces, I probably can just say or at least, well, let me go in here. I can put it here. I had some somewhere that was kind of doing this. I might have deleted it because I wasn't using it. It's something like this. I count up the number of grounded legs that I have. Well, it was really like each leg would apply. I don't know if it makes a difference if each individual leg applies anti-gravity on itself. I think center of mass, it should probably just be center of mass. With 3 legs, it can perfectly, it can do it perfectly with 3 legs. Yeah, I'll just say that. I do need the number of legs that are grounded, though. I guess I can... Maybe I can calculate this number, because I'm doing it twice. I'm counting it twice. I would prefer to just count it once. But I guess even then... it would still have to loop it anyway. I guess I can do calculate grounded legs or something, and then solve leg offsets can just use these numbers. I'll do that. I'll put it above this one because I know it's going to be before that. I could also just... I actually should probably do it in update legs because this will iterate each leg. It'll update the leg, and then I know if that leg is grounded or not. And I do need to remember how many I have grounded. Okay, I'll do that. And then I want to know this value. So after each leg update, I can say if leg is grounded, I'm starting that at 0. I mean, I should leave the 0 there. And then I'm calculating an average absolute displacement. I'm also calculating a leg displacement in general. Oh yeah, average is used here. Can the leg just include the ground offset? I guess I could say leg ground height offset. I mean, that's probably just too much optimization, I think. It's probably fine to just do this. Average absolute displacement. And then it's this line. And I'd say if actually really if it's greater than 1, then I divide it. And that should be all of that. I just have to change the names. Okay. These loops have merged. And then I will have a grounded leg count, so I can do anti-gravity, I guess. I think this is probably how it's gonna go. What about between that and, well, if grounded leg count is greater than 0. Grounded leg count times 2 over, is that correct? So with 6 legs total, if I have 3, it's 3 times 2, 6 over 6 is 1. If I have 2 legs, it's times 2, 4 over 6 is 2/3. 1 is 2, 2 over 6 is 1/3. That makes sense. But I will use is equal because I want to be sure that I'm not doing some slight rounding errors like 0 point a bunch of 9s. Desired acceleration will be, I guess I'm subtracting times this anti-gravity force, or I'm just doing that. Otherwise, it's desired acceleration subtracting times that. Okay. So this should be relative anti-gravity. Whoops. Need to multiply by this value here, otherwise it does that. It's an acceleration. Interesting. Why aren't you pulling down? It's gonna detach. It should detach and then fall. And then blast off. Okay. What? Oh! Right. Desired acceleration has to reset to 0 at the start of every frame, so... Okay, it's not blasting off. Cool. Alright. That's like the second time I've made those two mistakes as well. I don't multiply gravity by delta, and then I forget to reset it to 0. So I'm... Alright. I was trying really hard to make sure I clicked it correctly. It should just be able to scale that, no issue. I guess I didn't click as high up as I thought I did. It can definitely go there. I don't know why it's, Spitter's like he can move around me. Why are you not just go up? You did it before. What's its issue right now? This leg thing it's doing is kind of crazy. Go. Go. What the? What is this? How is it moving like this? None of it's all of its legs are like moving forward. That's super strange. Red is moved from scratch or Jolt has this built in? So it is physics based to an extent. Like I can push this thing and he'll be like, whoa, you know? Maybe we can shove him up the wall. To an extent, it's physics based. Maybe its springs are just like behaving strange. Like it really can't figure its spring out. But it is stuck on there. Oh, you haven't seen like any... Oh. You haven't seen like any of this stuff. I'll show you what I've got. I'll turn this on. And then... I'll turn all of this on. Do I remember how to... I don't. Is it this? Oh, there we go. Third person. So I'm using a raycast, or I guess a shapecast camera. It's just so I can see it. I don't think I'm going to have third person in, and I've heard this camera's really weird, and when I play with this camera, it feels really weird. It doesn't seem right. Like I don't know what third person games do to make movement not strange. But yeah. I kind of have a fake reticle just because the sphere cast perfectly divides the screen as the debug shape. Friction is not very good right now, but this character controller is also physically based, so I can stand this on this moving platform, or this one's going to hit me first, so it's going to launch me. Right. So that's just a rigid body simulation. This I have to do myself. I can make a moving platform and then stand on it. You can see this like green shape at the bottom. Maybe I should turn this off. I think I can just hide this really quickly. Yep. Okay, so I turned off the mesh. So you can see this green sphere at the bottom. That's just a spring for not sticking to the ground, but for moving. Which means I can go up small inclines pretty easily without too much problem. I can go upstairs. I have thought that I probably want to like revisit stairs and make them a little sticky somehow, because right now you just fly off them. If I walk on this thing, I am applying a force back onto it, so I think I should be able to flip it around. Okay, my guy doesn't have much mass, but I am technically acting back on it when I walk on it. I could make the player more massive, so I can actually, because I could reverse the spin direction by running along the same direction that it spins in, or I could accelerate it by going backwards. This box I can push. I also have crouching. It's really jumpy when you uncrouch. I'll still have to figure that out. These are balls, but they like launch into space when I walk onto them, usually, like that. I have steep slopes. You can see the spring, the debug spring looks a bit weird, but technically it's casting through it and sticking me on the ground, so it's not. If I go in the first person, it just looks like it's a wall. I can currently like almost, you can kind of like wall jump. It's not intentional, but I guess I'm gonna leave it. Just walls. And then I have this. If I can jump on it. So I move alongside things. The collision boxes look really jittery, but there's interpolation on, so it doesn't look really bad first person. This will just launch me. At this elevator. I can stand beneath it if I get there fast enough. Nope. So that brings me up. I can stand underneath it and it will kind of squash me. Moving platforms. What is the environment lore-wise? You're on a planet, and you're gonna blow up the planet. That's the environment so far. This is just all test stuff. It's just a test level. And then I'm working on this creature, the crawler. I say creature, it's actually a robot. It behaves weirdly when its legs are on surfaces. It's gonna freak out eventually. It doesn't look so bad right now, but it will freak out. It's kind of freaking out, yeah. Yeah, I still got work to do on it. Finally, a playable evil? Well, it's not necessarily evil. Eventually I'll have it so he's also reacting to the movement of the surface. See, right now he does not care that the ground is turning beneath him. But if I were to walk him in front of this... Whoop, I don't want to be taken away. So that's a really cool thing that I've been wanting to have, was just like I can mess with him really hard. I could even launch him like that and it would be able to, I haven't programmed it to be able to recover. I think in that case I'm probably going to need to have some kind of animation to fix itself. I also have just the IK is really odd. The legs start twisting in ways that don't really make sense. But that'll be a thing to fix. Thanks to that, spider archers will finally be interesting for you. I mean, I'm sure theirs is almost purely animation. I'm sure there's... They do even more cheating than I do, I bet. But yeah, the general concept for me is that no collision point found. Oh, I get it. Okay, I'm gonna ignore that error. Parker spiders, you're in for a rabbit hole. If you have any like dev talks about them making those, I would like to see. I tried looking it up. All I got was like, after like a minute of searching, was just gameplay, showcases, and that was it. That's all I found. Alright, so I do have anti-gravity, but I'm confused why it can't walk up the wall. I'm confused by that. Because I tried it before. If I just set it to like pure... Wait, max. Whoops. Push. Push. Yeah, that looks more accurate, I think. Okay. So I'd probably put these back. Another thing I've been doing is making sure I have a lot of debug stuff. I've written my own nothing is actually visible right now. But if I did, I can turn on a bunch of debug stuff for this. Not that. Well, the lines are mine, so when I do like velocity normal stuff, those are... I have a vector thing. But if I go here... I could even turn this on just for maximum noise. They made a documentary about it on their official channel. So the green area is where it would like to place its feet. The red spheres are its current target, where it wants to move the leg to. The blue lines are the ground normal surface. You can see the orange text appear, which tells it, it's just a short printout of like, all right, I'm moving the leg for this reason. Oh, I didn't show this either. But I can do like quarter slow motion. I can even tick individually, then we go to a normal speed and then tick it. So every time I do this, it's doing a physics tick. So I can see at every frame, essentially, if it does a leg movement, why it does that movement. This one over here, stepping with front right leg. This leg took an early step, and then this leg said, I want to move because that leg moved. And then, I'm guessing it was this one earlier, said it was stepping with front left leg. So this one took an early step, and then this one wanted to move because that one was moving. So then the when it finally comes to rest, the comfort zones shrink, and the leg says it wants to move because it's not comfortable. You can even see, it's kind of hard to tell, it's mostly visible when it's in motion, but these targets can move, and the legs will keep up with that moving target. So right here, here's a good example. This red sphere is where the leg is going to, and the leg, that position is updating constantly, and the leg is still tracking it pretty well. Kind of well. It looks weird because it's in... it's not like in super slow motion, but in slower motion, the IK actually keeps up with the targets. The leg is actually there, just the IK looks like it's not there. Yeah, see, that was really smooth landing. I can hold the button down. Like super low frame rate. Okay. Dog, you were just out. I took my dog out literally right before I started, and he's made it 35 minutes. Okay, I'll be right back. Have fun walking your human. Alright, what was this? I don't have it open. I think I can actually close those now. I don't really need those anymore. Whoops, I pressed the wrong button and I closed a tab. Oh well.
Hello and welcome to Stockholm, capital of Sweden, a country in Northern Europe that's been punching well above its weight in terms of...
Alright, I'll save that for later. That's really long. It's definitely like an entertainment kind of video, it seems. Okay. Alright, so is that the reason why stuff was messed up though? I was doing a max. I definitely had it walking up the wall before and it would just kind of like fly off the wall. But it might also be partly due to its... Gotta line this up. Partly due to the legs being weird. And it kind of struggles to get up there. Yeah, this is strange. It just kind of comes to a stop at this angle. Okay. I guess I will turn this on and look at what it's doing. So that there isn't much there. There isn't much. There's some other channels with specific videos about the AI and art creators, but again, it's not from the devs themselves. Yeah, I don't... there's a certain level of technical that I want that only actual developers could provide. Oh, you know what I would like? I don't know why I didn't think of that. I kind of need a free cam, don't I? Alright, so what gets you stuck up here? Early step, everyone is doing an early step, and then they say not comfortable, and they do early step. So every single frame, this one is toggling. And some of them also toggle after that. Try a slight less curvy. Oh man, I can see what it's doing. You can, I don't know how obvious it is or how visible it is on stream, but this leg over here, every single tick is flipping between, it's trying to step literally every frame. Every single time that text change, it's doing a step. And then sometimes these two on this side will flip. for a frame. So, all right. There is supposed to be a delay on how fast they can take steps. Okay, so it seems like they're not being considered grounded. Which is strange. The ground raycast is not connecting. This is probably where I would actually want the sphere cast then, because that gives us some area. I could turn off the mesh for the ends of these. It should be this one. Yeah, I can turn off all these meshes. So I can see the raycasts. Do I have this on? Turn that on. I think I need that on to be able to see. Yeah, the raycast. Yeah, I have to have that on to see the raycast. Though I can't see the raycast anyway. Yeah, weird. I can't see the raycast anyway. Why not? I was able to see it before. Why can't I see it now? Oh, because they're not enabled. That's right. I forced them to update manually. I mean, I guess I could manually draw it. That's probably what I should do, is just draw it myself. So I'll do that. I'll check the debug. Target position. Oh, I guess they don't use that. Okay, so it should be that. And then is there like a better purple color? That's pretty good. I can't remember what I provide here. I think I can just provide a 0. Okay. All right, cool. I can see them. I will, I think, turn off collision shapes. And I guess I'm going to leave that normal just so I can see if it's technically grounded or not. Do I have... Okay. It's really strange looking. I could probably get that fixed. Sooner than later. Because it does misbehave really badly when it's kind of stationary, but also not. Like, which leg is moving right now? Because one of these legs is supposedly in motion. There's jitter going on. I'm pretty sure if I do it in slow motion, it'll, Okay, I thought slow motion would allow it to correct, but I guess not. Alright, whatever. Go. Go. Go? Oh, weird. Okay, so they are grounded because that vector... Okay, so the blue vector would be disappearing if they weren't grounded. So that's really strange that this one is... Yeah, it shouldn't be able to do that. I don't know why it's able to do that. Because it can't return true until it comes in here as is grounded. Time since grounded is less than step delay, which will be true. And it will return false. So the other ones are somehow not grounded, even though they're pretty clearly... Oh, nothing if grounded else and floating. So yeah, time since grounded is incorrect on this. Are the individual legs have a bad like step delay? 0.15. Yeah, because I'm seeing the two front legs are doing this nonstop. So okay. So I guess I just run this again and see how that happens. I'll have to turn on the debug thing. I'll have to like pause the game and step through the code to see why it's doing this. Because it's really strange that it behaves this way. I want to try and get it to a point where it is just toggling every single frame. Okay, I guess I'll just go here and hit do this. So I'm looking at leg front left. Okay, good. So is grounded. Is grounded should be true. Okay, so yeah, that's the issue. Time since moved is also 0. Maybe what I have to say is that... When does time since move reset? Time since move resets when we start to take a step. Maybe I also just need to say that time since grounded and time since moved need to be above this value. Though it is kind of a problem, though, because we're not moving. Because what can happen is this can get left as a value that's too small, so it will never take a step again. I guess time since moved. When do I ever read this value? If it moved recently. Okay, that's the one read that I do actually. So I'll say this. I will always tick this up, and then I reset it when I take a step. So maybe this will... I say maybe. It should stop the jitter. It should be like fully enforced now. There's still a couple leg things to fix, but yeah. At least now that problem won't happen. It won't forever be stuck walking, taking very short steps. I just want the reset here. It can never reset. I don't see any jitter happening. Yeah, I don't know what happens there. It, for some reason, just struggles forever to stop. It can never quite stop. Alright, go up there now. Without walking off the edge. Okay. So it should still be trying to move. I guess I'll make sure that's still trying to move. Okay, interesting. So it's like forever stepping, but it can't go up. Why can't it go up? Why is it not able to move up the wall anymore? I mean, I guess I can just turn on... I can turn on this normal debug stuff. So I can see it's forward. It's friction. I guess I can turn on normal, but that doesn't really do anything. It's possible it's a friction thing that stops it from going up the wall. Ah, okay. So its forward vector isn't... Yeah, so its forward vector is not correct there. The forward vector should be pointing up the wall at this point. So, and I didn't even see it move at all. I didn't even see it start ticking up at all. My forward vector will go up the surface. This one is not, for some reason. So why is that? What am I missing? In order to go up the wall, it needs some of these things like this. Force ground movement should be true by default. I mean, I guess what I should have done was pause it and look and see exactly where it's missing that calculation. I want to make this work. Alright, so it's going to go up there. It's pretty much there. I should be able to stop here. And hopefully it's on crawler character. Okay. So, do we have a desired forward? I mean, I guess I need to step over and see. Okay. Force ground movement should be true. Forward. Desired direction cross ground normal. Ah, okay. That might be my problem. I just remember that I always have ground normal pointing the same way. It is always pointing up, yep. So that's a mistake there. So the average normal, or the normal, should, I think, be the ground normal. Let's do this. Okay, it should be the average normal of all the legs. But I think technically what I want to do there is I keep saying this, I haven't done it yet. But I want some sort of statistical calculation for that, where I gather up all my normals, I compute some measurement. I do some measurement on them to allow me to determine like the average, and then from there determine any outliers and discard the outliers, and then take the average of the non-outliers. But I could be simpler than that. Let me see where that's happening. It's in ground. Yeah, see, ground normal is always up. At this point, I do have every leg. This is dead code here. I'll leave it there, though. I can't just average every contact point. Kind of the problem is that it's possible that the contact points average out to be nothing. So, I mean, let me think of that. They could only average to be nothing if every leg had... if the legs had like opposite normals, essentially. That would be the only possibility. So maybe it's not quite like that. All right, I'll just calculate an average normal. Which I can actually do inside of the leg updates as well. And just set that normal there. I could actually just set it here. One issue is that I do have to account for if the body is in contact with the ground. That should already be handled. That's actually already handled. I can probably just ignore any body contacts. Yeah, I'll just ignore any body contacts. I can't, actually. If my body is in collision with anything, do I? No, force integration doesn't do friction. Or custom integration doesn't technically handle friction. So when I turn on manual integration, I don't have to do friction myself. The physics engine still does that for me. I only have to do physics. I only have to do friction and stuff like that if it's not actually a rigid body collision. Like my character controller uses a shape cast. Then I have to do my own friction calculation. Okay, so here's what I'll do. Do any of these use the ground normal? I don't think so. They have their own ground normal. Yeah. They don't look at the body as ground normal at all. Oh. Alright, fine, I'll say 0. If the ground normal is 0, then I will say I'll fall back to my state transform basis y. Which should never happen. I feel like that should just never happen. Otherwise I normalize it there. Alright, and now I have it calculated neatly. Okay. So it should move exactly the same on the floor. It shouldn't have any problem with that. It's just averaging the same vectors every time. Now over here. Okay, it had a weird jump there, but I don't know if that was forward or not, so. Go. Its forward vector is pointing up. Alright, so it still gets stuck. It looks like this large green line that's teleporting everywhere is movement friction, very specifically friction computed from how it wants to move, which is weird because I believe I set that to 0. I set it to 0 right there. Ground friction 0. So that green vector friction movement debug. So this is just something standard here. If we're not slipping and ground velocity is not 0, I calculate movement friction, which takes in the direction of this body along the plane of the ground. Do I calculate that incorrectly? Ground direction is ground velocity normalized. Yeah, okay. So move friction. If speed in direction is greater than limit in direction, which is not true. Otherwise, it does calculate move friction. Which should just kind of be nothing. It shouldn't be, it should be calculating almost nothing. Alright, I guess I'll run and see why that vector is calculating so highly. You line up? Line up. So it looks fine, right? It looks fine, but then once it gets up here, then it spams out. It does seem like it slows down before it even gets here, though. And I think, actually, I think this is probably calculating right. This vector is... Okay, right now it looks like it's kind of pointing the same direction. But it's never really facing forward. It's only like facing to the side or back. Oh, which actually is kind of wrong, isn't it? Okay. Alright, let me see if... or where... what it's doing here. Alright, we're on crawler character. So speed in direction is negative, limit in direction. Okay, so yeah, this is not, it's not calculating here. It's calculating from calculate move friction. Go in here. Cosine theta ground direction dot forward. It looks like it's moving backwards right now on this frame. Like it's falling backwards, so this should be a negative value. Okay, so slightly negative value. We're good there, we're good there. We're not doing that. Okay, so loss is 1 minus that times deceleration. Is that 1? Is that correct? Should I be clamping that? No, but it seems like I'm decelerating before I even reach that point, is the thing. I don't think it's actually move friction doing it, because it looked like a normal value until I pretty much came to a stop, and then it starts teleporting around, right? I think this is just more or less kind of Okay, so move friction is added, I believe. So I do ground friction add, and ground friction is added together, right? So looking at this, this is trying to, I mean, I guess if I look at here, so the X, it's trying to push me forward, in fact. It's trying to push me up the surface, up the Y, and left on the ramp is where it's trying to push me. So it's actually trying to push me forward. So this one's definitely not doing it, because if this was pushing me forward, then I should go, you know, I should go shooting up there. So that's not it. We're not going to do a jump. So we add up our frictions, we do state linear velocity. My current linear velocity is slightly down, slightly down to the right and backwards is where my linear velocity is pointing right now. So after I add this, I end up with a upward movement. Still, oh, I'm going up, forward, and to the left. So I'm at, technically at this point I am going up the ramp. This has helped me go up the ramp. Okay, we're not slipping. State linear velocity. We're going to add a tick of gravity, which is going to bring me down, probably. Yeah, so now we have pretty big down motion. No spring. We're not stalled. We are on the floor. So speed and direction, dot with that. My new speed and direction is still backwards. My limit is 3. So I should get a good kick up the wall from this. So what is it doing? Forward. What's my forward right now? I can see here my forward is this yellow vector. It's pointing up the surface. So it is forward. Yeah, pretty much up the wall. I multiply it by my acceleration and my accel multiplier, which is, weirdly enough, greater than 1. I'm not sure why. And then the max of limit in direction minus speed in direction. I guess the smaller value between acceleration and acceleration multiplier. So my acceleration is, I think, 6. Yeah, 6 times slightly higher, so it's like 7. I'll say it's not actually 7. It's like 6.06 or something. So smaller value between 6.06 and this value. So the larger value between limit minus speed. So limit minus speed would be 3.05, something about there. 3.05. Over the state step. So this is a very large value. So it'll be multiplied by this one for sure. So forward, I expect to see like 6 something. Okay, they're about. Yeah, that makes sense. 4.6 up and then -4 forward, which, I mean, looking at it, I think the robot's about here. Actually. Yeah, the robot's right below this shadow. So it's like right here is where the robot is. So yeah, I mean, it's not exactly, it's not mostly up, but it is more up than forward. So that makes sense to me. So we add that to our linear velocity. And strangely, this has not overcome gravity. So I'm not sure how that's happening. I should be applying full anti-gravity. So if I look at desired acceleration, should just be full anti-gravity. Is that like 9.8 times 1/60? I guess 64. Yeah, so it's already applied full anti-gravity here. So that's strange. Because it was positive and then I added gravity to it and then it became not positive. And my acceleration isn't enough to overcome that. So that's why I've stalled here. But that's strange. I should be fully without... Gravity should be having no effect on me. Weird. I am setting it before I call it integrate forces. I don't like reset it anywhere. Yeah, I don't reset it before that call. Yeah, that's really weird. I don't get that. Alright, let's go up here. Okay. My linear velocity is slightly up, actually, at this point. Okay. Alright, it got really stuck there. Okay, so state shouldn't have been modified. Yeah, it's not modified. Anti-gravity is 1. Desired acceleration. Should just match straight to gravity. Yep. That matches gravity. So what happens here? Calculate ground force. What's my linear velocity right now? Still unchanged. Okay, that's a good forward direction. Speed and direction. Almost nothing. My limit is 3. Yeah, why did it get multiplied up a little bit? If is slipping is not true. Desired incline effect. Is this possibly what it is? I do have an incline effect. But yeah, it's actually affecting it according to my forward and my current up direction. So it's actually not doing anything. In fact, it's like a bonus right now. It's a very small bonus, in fact. So weirdly enough, I actually get extra acceleration going up the wall right now. If air friction is not approximately 0, reduce air friction up to forward movement amount. Okay, that still just looks like 0 to me. So it didn't do anything. If speed and direction, it is not. So we calculate that. Yeah, move friction is still pushing me forward, right? It's like it's pushing me forward. It's pushing me up and forward, right? So negative X is forward, positive Y is up. This is just like a left and right thing, which doesn't really matter. Yeah, quite confused. So I expect to see my linear velocity, at least the y, become anti-gravity. So I should see y is 0.153 something. Slightly higher than 0.153. After I hit step over. That's what I want to see. And it's not. So why did that happen? Oh, because desired acceleration is already multiplied by its acceleration. Right. I actually do not multiply it by time. I actually don't multiply it by time. Okay, I have to stop this because it's like in a buggy state. Okay. Take off all the breakpoints. All right. It just went right up the wall. Further? Nice. Okay, well. It can just go. Alright. Cool. Lots of errors printing. Lots of errors printing. Can I fix these? Calculate ground force. The normal must be... Ground normal must be normalized? What? Okay. Ground rail contact. Okay, so here's the thing. I guess I say at this point, if I'm not grounded, or like has... Oh, it's probably like is on floor. Right? So I probably should run is on floor to be true in this case. Or I guess I would say like... Start with false. These don't read that, do they? They don't. There's okay. There's some possible problems here. But I'll get there. Let me see specifically what this one does. If is on... Okay, so we don't... I'm not toggling it like that. So yeah, what I'll do here is I'll just say... If ground leg count is 0, then I say if not is on floor, then I would say is on floor. True. Try to match it like that. And then I have an else. I would set it false at this point. And then I guess I need to clear all that too. Well, okay, let me skip doing that there. Let me not do that there. Let me do it here. And then that should just be a return. Otherwise, I'm calculating all of this stuff. Ground velocity is ground normal. I'm also just not even calculating the ground friction. Okay. Alright, so I'm just going to watch this until it prints some errors, and I guess I should have looked at the other errors that were happening. But oh well. Okay, I just got an error. Oh, this one happened at the very start. Really? What? Oh. It's like the first tick, it's weird. Is it? Oh, yeah, it's supposed to be written like that. Yeah. That's how it's supposed to be written. Okay, 60 errors, that's correct. It's not an error. Okay. Alright, no errors printing in. It looks like it's doing anti-gravity correctly. Okay. Nice. Check that. I've tested it. It's pretty good. Now I just have weird leg movements to fix. Some spring things are happening. Yeah, I'll have to... I guess what I probably need to do, my method here will be to try to write down everything that looks like is happening. I had one case just then where the legs were like swinging back and forth. Try to document exactly what I'm seeing happen for all of the problems. And then hopefully from there I can make a good guess of where I should start fixing, because it looks like there's probably a couple things going wrong that are making everything look weird. It could either be several things, or it could be one. It could be like a single line of code. Hopefully, you know, my goal is to try and minimize what I'm doing, so I'm not running in circles. I don't fix one bug and then that wasn't even the real bug. I just like masked the more serious bug and then it still happens anyway. That kind of thing. Okay. A hard problem. Possibly a difficult problem. I will turn off the step reason. Ground raycast draw. I am always ticking up time since move, and then I'm double checking that. I reset it when I start to move. And that's, I was always looking at that and thinking, time since moved more tells me how long has it been since I last stepped. Not necessarily how long have I been moving for. Which I'm sure I probably did some cleanup before, which this whole like leg can step function has been changing so much that originally I did have a need to only take it up when I was moving, and now I've taken that out completely. So time since grounded is now the main thing, but I also still need to make sure I'm not taking infinite steps. I think it's a better place there. I think it's in a better place. All right, this one I should just be able to open this or like close it and open it and then hit save and then it will be fixed. It'll change those nulls to just being not there. Yeah, the nulls are gone. And then I'm gonna turn the boxes back on. Because the debug draw should be, yeah, it is drawing over top of them anyway, so I didn't really need to turn them off. I turned them off because I thought the normal raycast was drawing, and that raycast can be hidden by the boxes. But since I have it disabled and I manually cast it, it doesn't do its own debug drawing anymore, so hiding the boxes doesn't reveal anything because it's not even drawing. And I think I turned on all the player stuff. No, I turned on all of this one's stuff. Okay. Wall climbing tested, it worked. Anti-gravity worked. I don't have a way to stop it from using legs. I know in the Minecraft mod, he has like a tool where he can force a leg to stay off the ground. Which is probably a great debug tool, but I have no idea. That'll be a difficult thing for me to get. I have to turn on a crosshair. I have to have some kind of button sign set up for it, or just some way to click it. I don't know. I don't have an inventory. It works better in Minecraft because Minecraft has a full inventory and item selection thing. You can just literally, I think he was using shears. He could just hold shears and right click the leg, and he doesn't have to code any of that. He just looks for the click and then he says, oh, am I holding shears? Okay, then it was, you know, do some behavior here. I don't have any of that. All right, but this is in a better place. I'm moving that loop out to just within the same leg update loop. Then I can collect the normals and all of that. Anti-gravity is correct. I have to reset acceleration. I do a min, so if it's over 1, then it clamps to 1. Yeah, I think I'll just probably stick with the desired acceleration. I could possibly have some kind of anti-gravity. Maybe what I should do is have a proper... I'm going to do that. I'm going to change it. I want to do that. I don't... Desired acceleration, I don't really like so much because it doesn't have like a good name. It's just some extra thing. And I'm only using it for anti-gravity. So I'll just literally say desired anti-gravity. And I just have like, it'll just be like a multiplier. Or I guess I can say desired gravity. And this can just be a float. Which will be left on 1. And this will be multiplier to gravity force. Or I guess multiplier to gravity acceleration. I could go in here and set gravity scale. But I'm kind of worried about changing it like that. I mean, I guess it is intended to be used that way, isn't it? I think... Let me go see the exact code for this, because I can verify if it's going to work before I even try it. Because I guess I can probably look for it here. Because total gravity, I have learned that I can't set the value. I can't write to it. I can only read from it. So my thinking is it's probably, my hope is that it just is not some pre-calculated value, and every time I call it, it's checking the body's location or area effects. I think area effect only applies on a single tick. It doesn't check it every time. But my hope is that get total gravity literally just includes a multiplier. Or the final call has some multiplier. Okay, strange. Why is it not here? Body gravity. That's that one. Body get gravity. Okay. Return gravity. Okay. I do have gravity scale. Is that part of... All right, I guess... Yeah. Okay, I'll say that. I'm dropping desired acceleration. And then total gravity. Total gravity is not 0. I guess then I can also say and if total gravity is not 0 and gravity scale is not 0, then I will do this. I will do... Let me check. Yeah. Though I feel like total gravity... I mean, this is... Okay, this is the thing. Yeah, the total gravity vector currently being applied to this body, I think gravity scale... Yeah, it actually does. Never mind. Okay. I cannot use this. I have to also say I do need a custom... Yeah, because I think that setting gravity scale doesn't... Well, maybe. It will be a tick delay late. If it doesn't update it right away when I set it, then it will just be a tick late. But I also don't want it to be a tick late. If I know that all of my legs are grounded right now, I want to do anti-gravity now. Okay. I will do this. State total gravity plus... I guess this should be... Oh yeah, you know what? Let me put this at the top. Let me calculate gravity at the top. Dog, nope. Nope, you don't need to go. It hasn't been 2 hours. It's barely been an hour. Yeah. Now I can just write this. No. No. Then I can just say if not gravity is 0 approx. Okay. So that's the only place I should be using that. Now up here, I can simply say it's not a big deal to set it. In fact, I can just set it here. Anti-gravity goes up, so I'll say 1 minus this value. And that's all I have to do. I can also just set it to be that, because then this would be 0. But I can also just skip all of that. And then I guess I'll say between 0 and this value so that we don't go negative, so we don't float up. Okay, so same thing, right? Will you topple? Can I make you topple? Yep, nice, okay. All right. Cool. Go higher. Come back down. It really just likes to crab. I don't know why. I mean, that's just going to be like a fix kind of thing where I tell it like, yeah, you can start walking, but like prioritize turning over walking. Okay, cool. I have. Okay, no, those were non-errors. Congratulations. Yep. I cleaned it up just a little bit, but it was already working. Okay. The movement got better, or am I imagining it? Nope. It shouldn't have gotten better. Maybe a little bit, because I did a small fix to the legs, which allowed it to walk up the wall. Well, there's a problem with the leg, first of all. That was a bug that I needed to fix. It wasn't really necessary to fix it. The real problem was that my anti-gravity wasn't full, like properly anti-gravity. So I have my actual gravity calculation, which can be modulated by a desired gravity value, which can change anytime. I'm pretty sure total gravity is the physics steps. It checks all the intersections and it says, all right, here's your total gravity for the next frame. And then that is also multiplied by a gravity scale. So I can't just change gravity scale. And it's already factored in. So gravity scale will always be like a tick behind. And I don't want that. And then I made sure that gravity is also just computed once at the start. And then I just use a gravity vector instead of state total gravity. Okay, so that should really be everything. All right. I'll add all of it. A few of them don't sync with the other one moving. They really try, they aggressively try to synchronize with themselves, which is what I want them to do. But the problem there was that they were allowed to take a step instantly when they weren't meant to be. So I make it so that I fixed it so they hard delay themselves if they need to. If they're on the ground, they need to like stay on the ground for some amount of time, and also wait to move as well. That was kind of the issue. They weren't waiting after moving. If their movement kept them grounded, then they would just continuously try to step. So add anti-gravity, the crawler, fix instant stepping. Anti-gravity based on number of grounded legs. I guess it should be like replaced. With desired gravity and uses of state total gravity. I burned and bit my tongue on the same day. Yeah. Yeah, that happens. I think I've done that at the exact same time myself. Like, I'll have hot food and it's just too hot. And I think I've done that before, where I just somehow I bite my tongue at the exact same moment. Actually, I'm thinking of like biting my cheek probably. At the exact same moment. Like it was that shocking. Change time since move to always count. And check the value for stepping when already grounded. Okay. I can imagine that. I mean, there's a thing where, like, if you're some people in their sleep, they'll just like, kind of like rub your teeth together like you're chewing. So that could happen. It could just be from that. I say some people. I think everyone will do it eventually. Just sometimes more than others. Okay, so now I have like an actual dedicated desired gravity value. Okay. Now I probably want to make it so the legs don't do this. I'd like to fix this. Okay, I'm not this. That's, I don't care about that right now. Okay, so it's not doing it on flat ground. My brain doesn't get used to it. Patches that, yeah. Maybe that step thing fixed this. Okay, so yeah, on inclines, it really struggles. It's basically stuck doing something forever right now. I don't know what it's doing. It's literally stuck forever. I don't think any of the legs are trying to move. They all look like they're in a comfort zone. To me, they look like they're all in their comfort zone. Yeah, it's totally stuck. Okay, so that's what I want to fix. I want to fix that happening. Maybe the right way to go about it is to fix the first problem you see happen. Because this kind of is the first problem I see happen. On flat ground, it can figure itself out pretty quickly. But if it has any leg on even slightly inclined ground, yep, it's just stuck. What the hell was that? That leg in the back just like teleported really hard. Yeah, as soon as a leg is like on some surface that's not the same as everyone else, then it's really... That's really weird. Why is it doing this? Is there some interpolation happening? No. I don't know why this target is moving like that. That target's really weird. We were timing. I can't imagine Microsoft patching their OS for de novo, or is this just a weird coincidence? What is that? Well, the thing is, they don't have to do that. That's the thing. That's actually kind of the crazy thing. They don't have to make anti-cheats or anti-whatever it is, piracy stuff, whatever. They don't need to make it work. That's crazy. What is it doing? Yeah, okay, so I gotta figure that out. That seems like a main problem. It really cannot handle a single leg being out of plane. So it's not leg stall when stopping. It looks like behavior with the legs elevated above the body. It is like this. Okay, so my problem is, I mean, I'm fixing it. I don't know, I'm gonna do like a real investigation of this. I should probably get lunch. Weird legs. The removal of trust for all kernel drivers signed by the deprecated cross-sign root program. I guess I just don't really understand that. The removal of trust for all kernel drivers signed by the deprecated... It sounds like to me it's just an extra step. is what that sounds like. Because I'm assuming you could still just go into Windows and tell it, hey, trust this. Like, it sounds like it's just changing the default. Oh yeah, it literally says it. Ensuring that only kernel drivers of the Windows hardware compatibility program have passed and been signed can be loaded by default. So it's literally just an extra step. I don't think that does anything. I don't know if it's necessary them. If it is de novo, then they are just that stupid. It must just be an extra step where you have to say, oh, by the way, trust this. Trust this driver. Okay, now we can run hypervisor cracks. Okay, so I noticed the legs freeze if any leg is on a different plane. Is on a different plane. Actually, let me do a better test because technically that's an incline. Let's go over here. This disc is a flat platform. So if I put one leg on this, do they all freeze? Try to get one leg on here. Oh no, it's fine. It looks like it's totally fine. Yeah, it's doing just fine. Spin and put 2 up there. Yeah, it looks fine. It was struggling a little bit to equalize, but it did equalize. What if we get 2 legs up there? Okay. It does look a bit like an over extension here. That doesn't really make sense to me. I wonder if I can get 3 legs on there. Yeah, that doesn't really make sense to me. That seems like it's way too far. For such a small addition, its rest locations are like way out of place. Does this look natural to me too? Does the location of the legs look okay? I mean, I guess I shouldn't even ask that question because the rest positions are kind of crazy. I would expect to see the rest positions pretty much be where the legs actually are. They're over-rotated, is what it looks like to me. Yeah, this doesn't really make any sense. It could just be that the leg springs are way too stiff. That's a possibility. Maybe I can see that one first. Maybe I'll try to fix that one first. Because the only thing that should happen is that the springs will just try to push up maybe... I mean, what is the distance between this and the floor? Can't even click it. Rotating floor, collider. So it's a height of 0.15. Which, if it is trying to lift that body... Now 0.15 up, I guess that makes sense. It should be targeting the average offset, I think. Yeah, I think it right. It should be limited to the average offset. So I compute my average leg displacement, and it's limited to this value, which means if half the legs are at 0 and half of them are 0.15, then the offset I should see is like 7 centimeters, a little over 7 centimeters. But it seems like the body rotation is just kind of excessive. But it is purely worked on by the springs. I don't have any... I have a lot of code here, but it is set to 0. So it's actually not doing any angular pitch and roll corrections. It does look excessive though. Why is that? Really, I would think it should look like it's barely rotated. I think it should look like it's barely rotated. Okay, let me look at all the forces when we're on the surface. I should just be able to put it like that and it will... Okay. All right. So let me see what we got. So this one's offset is... This is the front. The front left leg, which is this one. Okay, let me just hit continue then and see the next one. This one's offset is nothing as well. I mean, I guess that's what I expected to see. Once it's equalized, the offset should be really close to 0. But the body tilt is just kind of insane. It's a bit insane. All right, you know what I really want to see? I want to see where I calculate this ground offset again. Okay, so the normal is still like that, and it is up. It just doesn't seem right. Why doesn't it seem right? Maybe. So what I'm really doing is I'm taking that ground plane, I'm extending it out directly underneath the body, and I draw that line up. Maybe what I should do is, instead of doing the line from like this leg, instead of doing like tracing the plane over here and then drawing it up, I should probably take this, or take the attachment point, shift it out to be above this, and then measure that distance. Because that will fix that rotation quite a lot, actually. So if I take that attachment point, I guess if I take the plane, not the ground plane, but the attachment point plane. So I take the normal of the ground and then the point, the attachment point, the translated attachment point, as the plane. And then I take the distance from that ground point to that collision plane. That will give me, I think, a better understanding of the offset. Let me try that. So the ground normal, instead I want so instead of the ground plane, this is going to be the body plane. It'll be a plane of that'll just be the same thing. Oh no, because if I translate the attachment points... No, it shouldn't be the same thing. Because the point stays here and this plane will move, right? Yeah, okay. Well, what'll really happen is the plane will move up slightly as the body moves. What I'm thinking I do is I take yeah, okay. I'm doing body plane. So I don't actually use ground normal here, which seems odd to me. And this is just a pure distance, so it shouldn't come with a sign. All right, I'm gonna have to take the dog out. Distance will be positive, below the distance will be negative. Yeah, I'll just flip that sign around. And it will be times the attachment point, and then this will be body plane, distance to ground point. See what that does. Take that off. It's a lot better rotation, for sure. That's way better. And its rest points look better, too. The rest points actually align, are close to where the feet actually sit. Yeah, see, the rest points are like exactly where they should be. They're not weirdly in the ground anymore. Okay. Face me like this. Yeah, that looks way better. Though it's possible this could probably be like a mistake in a way. So I'm definitely gonna have to move this guy around and like really check. Yeah, so you still can't really handle extreme changes very well. Yeah, okay, so I'll have to figure that out. That's still kind of an issue. I gotta take the dog out. Alright, I'm gonna send this guy up the wall, and then I'm walking away. I will be back. I'm gonna grab food too, so I'll be back with food. I'm back. I've got food and I'm going to eat. What is that? All right. So it's still an issue where if like it seems like if a normal is wrong, then it totally screws up. Something it can't cope with. What the hell? Why are they moving? Something interesting is happening here. I essentially cannot see the robot moving, or even its leg points moving. But I look over at the preview, and there's a ton of shimmering, which means they're moving. It's like some kind of motion amplifier preview that I have. They're not moving to me. Like visually, to me, I don't see them moving. In the preview, they're jittering like crazy. Interesting. Oh, right. I was gonna look at this. But what is this? Yep. I'll watch the other video after this one. Right, the grapple. And you can kick bullets, and you can parry bullets. Not the best teaser trailer, but sure. I think gameplay beats everything, and I've already seen all the gameplay. This doesn't look like they've added anything new. This is more like a story, almost. Like there's some art style. But cool. All right, yeah. This is really long though, so I'm gonna increase the speed a little bit.
Quite a while.
Stockholm is the home of Embark Studios, the creators of Arc Raiders, and for the past few years I've been documenting the development of this game. But while most games change over the course of development, the story of Arc Raiders is a unique one. Because not only has this game changed dramatically, but the original version of the game that was shown to the public no longer exists. And ever since it was first shown, the internet has been asking one question: what exactly happened to that version of the game? When the Arc Raider teaser trailer was first shown to the world at the Game Awards in 2021, it was a very different game. You see, back then it was being pitched as a co-op PvE experience with players able to jump high and run across a wide open map, working together to defeat massive machines with emergent behaviors. Players selected their characters from a set of defined heroes, and crucially, it was a free-to-play game. Over the next 4 years, Arc Raiders would evolve into something very different, a PvP-VE extraction game with denser, more lived-in levels. Very different, a PvP free-to-play game. Over the next 4 years, Arc Raiders would have...
Look at this. Oh my god. They cheated so much. They cheated so much. You know what's crazy? I didn't see this. I didn't know they did this. I very specifically remember recently saying, we're forgetting how to do this stuff because we are literally just plugging it into a neural network and creating the software. We're growing the software. That's literally what they did. They said, forget trying to program a crawling thing. We're gonna machine learning train it. I hope they didn't actually use this. I hope this is just like a test or something and they straight up didn't use this. I don't see any reason they could not have done what I'm doing and just written the code. 200, 300 lines of code or weeks and weeks of training something and getting it wrong constantly and retrying until it's close enough to acceptable. I really hope they didn't do this. But I see joint limit penalty, reached reward, heading reward, target velocity reward, and ML agents training in a difficult environment. Like, there's no way they actually, if this is correct, ground contact penalty, reset on fall over module. I'm sad. I'm sad about that. It's literally going to be at the point where we don't even have, we're not even like writing AI behavior trees. We're writing down prompts and training growing software to do your AI, like straight up all the way. Not a single line of code written, all prompted. And we're going to forget how to do it. We're literally not going to know how this stuff even works, because it's literally just a black box of sensory inputs and motor outputs. We're literally not going to know how it works. I mean, if this drives the in-game AI right now for these, or for whatever these crawling creatures have become in the game, then I'm really sad. Because myself in like 15 days already have something better than this.
Evolve into...
In my opinion. I would say that if they're training it to walk on terrain right now, I'm days away from this. In the same time span, they're probably still trying to even get it to like start even to begin training on the same time period. They're probably not even training yet.
Something very different. A PvP VE extraction.
I hope
with
that's not
denser, more
the final
lived-in
result.
levels.
I hope they just
Machines
said,
of all shapes and sizes with
I could just program it.
driven by physics and
And then they would.
locomotion tech, turning a once arcadey experience into something far more grounded. In this three-part series, we're going to reveal not only why the original concept was killed, but how the current version of Arc Raiders rose from the ashes of that project. We're going to detail the bleeding-edge locomotion technology powering the movement of their most intimidating machines, how
Bleeding edge. Bleeding edge technology. We just did a AI warehouse method. That's not an insult to AI warehouse, or if that's even the right name of the channel, but it's like it's really just like, can we do it? Can we do it? This is like, we can't do it. We need software to generate it for us. I hope he gets in there and says, oh, an early iteration, and now they... Hopefully.
Things like gunplay and loot evolved over the years, why they dropped free-to-play, the impressive work done by the audio team, and much more. But first things first though, to fully understand what happened to Arc Raiders, the game that was meant to kickstart this new studio, we have to go back to the founding of Embark itself.
How did this new studio come about? And most importantly, how did they decide what type of games they wanted to make?
Also, I will say it's a little weird to style this as if it's a documentary when it's been uploaded by the developers. It's not a documentary. It's not a documentary. Did they make it good? Oh, it's great. Look at, I mean, it's not a documentary.
A lot of the initial
There's no original
companies
opinions
in
in
Embark,
this.
and the founders came from DICE, and I've been in the industry for close to 20 years. Most of that spent with the people here. I shipped 21 games while at EA, I think.
During my 20 years of building games or more, you know, the first game we built, we were 7 people in an apartment basically, you know, to then, you know, the
games while at
Minimum requirements to enter the industry. You got to release 10 Battlefield games.
EA, I think.
During my 20 years of building games or more, you know, the first game we built, we were 7 people in an apartment basically, you know, to then oversee productions with over 1,000 people. Are the games themselves better? There are more of them, they're at higher fidelity, but are they actually better games? How do we move away from productions that are so large that they're difficult to manage?
I mean, I was part of the group, the founders group, so I was here when we were 6 people. Technology-wise, I mean, we quickly settled on Unreal, and then in conjunction with that, we also had proprietary tech that we were developing, and then also, of course, invested heavily on procedural tools, especially for the content team.
The initial gang sat around a big table and discussed things that we want. want to explore, and games that we want to try and see if this fits into something that we want to do. So we started this endeavor of making micro pitches. That we would come up with a simple game concept and talk about it for just a couple of minutes. And we started doing this over and over, we started seeing common thematics. They slowly formed into the initial pitch for what we wanted to make, so we pitched it to ourselves. A couple of these explorations were left by the wayside. One of them became the finals.
A couple of thematics that we knew we were excited about was, of course, the prospect of space travel, the impending sort of ecological collapse, the rise of AI and the man versus
I don't have an issue with
machine
procedural
angle.
if you're
So it's a
doing,
game
if you
in
need
there,
it.
and
There's a point where procedural, you need it. All right, you're not going to make 2 billion Minecraft worlds without procedural. You're not making No Man's Sky without procedural. Hopefully, hopefully though, there is a lot of intentional design. You're not 100% generated. Like maybe No Man's Sky would have been nice if they had like actual cities with some intention, you know, large intentional structures, and not just a collection of, what do they do? Whatever you would call those. Little bed chambers or something around a flag post for like 90% of the structures in the game.
I think when we were the first in
Especially for like customization, in some way there needs to be procedural stuff there. Like if you're making a bunch of armor for Halo Reach, it has to have like attachment points, and you have the attachments you can go on there, but it's all still intentionally designed. But the actual production of that placement is procedural.
initial group, sort of vetting different concepts.
This guy feels
those
slightly
were
to
the
me.
things
It
that were
is a
sticky
bit
in
empty.
there. I think from a mechanic.
The space stations are the most intentional things. And even then, that's like, they've gotten better. But I would like to see stuff on surface. I'd like to see surface stuff. As far as I'm aware, there is no large surface structures. The biggest thing is like Robot Outpost, which is just a big pillar that summons robots to fight. And then there's like big, essentially parking garages for ships, which is just like a mini space station on the ground.
Perspective, I think the first pitch was something along the lines of session-based raids. To give you an idea, we talked about some sort of Venn diagram between Shadow of the Colossus, Left 4 Dead, and PUBG. Somewhere in the middle there was a game concept that, I mean, on paper, was a super compelling concept to us, especially the making you a small human in a vast world with huge machines. That's what we started to explore, not knowing at all what kind of game loop we were supposed to have, but just like looking at the prospects of different mechanics in that context.
So we wanted to make something completely our own. And everyone had an idea of something fantastical, sci-fi leaning, because it's comfortable. Everyone kind of likes it, but it's also a challenge to carve out your own niche in that. And it was certainly challenging. Even my kid, who was like 11 or 12 at the time, just had the sentiment going, "Oh, new studio, sci-fi game, very original."
Embark's first game was going to define the studio, and they wanted to work on something that was outside of their familiar first-person military backgrounds, a game that was on the bleeding edge of technological innovation. The team entered a long period of brainstorming and ideation as the studio slowly built up around them, a process.
Yeah, there was a weird sentence in there where he said, in between PUBG, whatever other 2 games he named, we want to make something that's totally our own. What? You can't say you're making a blend of 3 games and then say it's your own thing. I don't know. It's a pretentious way to say that. Like in my mind, how I came up with my idea was just like, what is something, I think I probably started that. I was like, what is something really cool that happens? You blow up a planet. Like that was just that's literally how it started. I was like, all right, what's something really cool that happens? Okay, why does it happen? What's the point of it? All right, why are you, it's the questions. I'm answering the questions. I don't go in there saying, well, I guess I do say, I want there to be guns and for you to shoot robots. But I'm not like, let me make Arc Raiders and Halo. I'm not saying that.
That
No, it's a
gave
weird way
them
to say it.
many of their most attractive ideas, but also created significant design cul-de-sacs that would prove troublesome down the road. This project was known internally as Pioneer.
We developed, I think, core mechanics at the same time as we were testing out some initial ideas about the game mode itself. No one was thinking about a larger meta game at that time. Like, what is the actual economy that drives the players' motivations and so on. We were literally exploring the initial mechanics of how does it feel to play against these machines, and because I think all games needs to go through that. Like, is there something fun in the second-to-second mechanics? Like, is it fun to even in FIFA? If it's not fun to kick a ball against the wall, it's not going to be a fun football game. Sort of put these long.
I mean, I think there is probably a problem with game designers where they focus more on trying to copy elements from other games. Where they specifically start, I mean, part of it is that, you obviously don't want to, you don't have to go totally alone. You can say, all right, well, I know for a fact that guns are cool. Guns are fun in games, so I could have guns. Or I know that driving is fun. People play driving games. And from there you can say, all right, what if I mix those two together? Whatever that game was where you're doing, like, it's Battle Royale with cars. Right? But it seems like in my mind, they base their whole... Some of them will try to base the entire game off of specifically pulling things that exist from other games. Instead of saying, I know guns are fun in games, let me make some fun guns. There's a plasma grenade in Halo, let me make the plasma grenade. Let me make my own version of that. I mean, it's fine. If you're like ideating and you're like, okay, what if I make a grenade that sticks to something? I mean, that's not a hard concept to think of. But it's more like the approach is wrong. I think they stick themselves into specifically trying to copy pieces of other games. And then when they talk about their game, they're talking about how it's just like this other game. Because that's what they think that they're doing. They think that they're just making some extension of some other game.
Large machines in this large world, and I mean, we're again testing out playing against these large machines just from a pure sort of game and spectacle. There was something there.
You can say it was an extremely ambitious project. It's supposed to be a new genre, or was supposed to be a new genre, and session-based raid with, say, 40 players. And you're supposed to take down huge obstacles together, like big bosses. Genre, an ambitious project. It's supposed to be a new genre, or was supposed to be a new genre.
Okay, he corrected himself. He says it's supposed to be a new genre, or was supposed to be. Marathon did it first. At the very least, Marathon did it first. I don't know what other games came out. I'm sure this is not, like, new genre. At the very least, this is just Marathon. Sort of, right? I don't know. But it's weird. I was hoping they get to development. They're not. They're just jerking themselves off, talking about how well he designed this game.
Obstacles together, like big bosses, big AI enemies that evolve over time. So every time you go...
Talking about the old version? I mean, they say it's the old version. It just sounds like the same game. It sounds like the only difference is that the environment is different.
You play against
it's not a what is it? It's not Helljumper's environment. It's maybe more like I don't know,
new
cities,
version
right?
of the
They have
AI.
cities.
3 to 4 teams or more, I don't remember, but scattered out in a big world. And at some point, giant machines would arrive. Look, it was already populated with smaller machines, but then we would have these larger machines arrive, and then we would sort of have the surviving players would then converge into these epic moments at the end tail of a session. We had some amazing playtests and amazing moments when we did that, and we saw the potential there. And we wanted to believe that we could replicate that on a consistent basis. But that's where where the sober eye should have come perhaps a little bit earlier than we wanted. We wanted to believe that we had something there, that there are some incredible moments in there. But the individual player there, if we were being honest with ourselves and looking at the game with the lens of trying to capitalize on that and make a game out of that, again, consistently replicating a player session that would hold those moments over and over again, I think that was much harder than we thought.
This version of the game, now known as Pio 1, was a very different game to the Arc Raiders we know today. Player movement was far more bombastic, characters were powerful, adopted the personas of various heroes.
Chill with the
worked
screen
collaboratively
shake, oh
to
my
hunt
god.
down these
Can't
large
see anything.
machines. Very different to Arc Raiders in terms of both gameplay and tone. But many fundamental aspects of the game were developed in this period. Highly detailed, vast open terrain, the feel of the weapons, the look of the world. One such aspect, the technology driving the locomotion of these large robots, is going to require its very own video in this series. So look out for that soon.
Episode 1, Episode 2, jeez.
What's exciting and what's still exciting is the fact that using this
It,
technology
that
for our
seeing how that thing was
locomotion
moving,
is the
they
door that opens up when
Machine
you
learning,
are training something
neural network.
to behave and walk by itself.
Here's the issue with that. It's inefficient, and it greatly limits how many of these you can have on screen at the same time. It looks like they have one. In all their clips so far, it's been one. Their CPU budget is like one of those guys on screen at a
And
time.
the nature, like when this player starts interacting with that and losing limbs, and still it wants to stand up, it just opens that door to a new type of experience that players haven't had before, I think. They're literally playing against a machine.
We spent the majority of our first year just building tools. I also knew that
I think they
we
mixed
weren't
up.
going to get things right.
I think they forgot that they can just program it and it's still fighting a machine.
That we were going to make a ton of mistakes along the way, and we had to plan for those mistakes.
Oh. That's what my crawler's gonna look like soon, actually.
First year just building tools.
It's just gonna hover towards
I also
me
knew that
when I
we
remove
weren't
the
going to
leg.
get things right. That we were going to make a ton of mistakes along the way, and we had to plan for those mistakes and kind of get ourselves in a cushion to be able to make those mistakes. Guess what? You know, if you're trying to send people to Mars, you will crash a bunch of rockets. We crashed a bunch of rockets.
I remember one of the earliest things I worked on.
Is that a SpaceX reference? I'm pretty sure we didn't crash every single rocket we launched into orbit when we were trying to get to the moon. But
Was the dog? Do you remember like the four-legged little pouncing thing that ran around the world?
Yeah, that's long gone.
Yeah, it's long gone. But that was one of the first things that I started working on.
Sometimes ideas written down on paper or that people talk about, like, oh, it'll be so cool, we'll have these enormous things and they can come down and you can fight them. And then in practice, when you put them into the game and you kind of go, okay, well, how does this actually work? It sounded really cool when we were talking about it, but actually now I'm just running around looking up all the time because it's 200 meters tall. And how do we even get up there? And what happens if I fall off?
Well, I think one of the core problems was that what we were building then was something pretty new in terms of like how the gameplay would be, and it felt like we were moving in the same direction, but then with the pandemic, we started to drift apart quite a lot.
The way we built the game
Really hear about
before was
Elon?
very loose.
I don't
That
think
kind of
so.
Mixing pot produces a lot of cool moments, and we just couldn't find the nugget that makes you want to persist. What is
From what
the
I saw, he's
main
still really active on
retention
Twitter.
mechanic
He posts a bunch of
behind
AI
some of all
videos.
this, what's in the mixing pot of fun experiences?
I remember they had this like sort of crazy idea about projectiles that would remove the parts of the enemies. So that was one of the first things I actually worked on, was a function for the launchers that we had to be able to like suck off the plates on one of the kind of bigger scarab bots that we had.
Suck
Finding
off the
fun
plates?
is
Why did she
always
say
a
it like
thing
that?
You cannot just automatically say that we'll just do this and it will be fun. What you know is like you work and you put the thing in and it's not working as you want it to. So then you need to start reworking it and reiterating on it and maybe rethinking some of your initial.
It's just so weird how they talk. It's actually really weird how they're talking right now. They're talking like someone's first month of programming with Python. Sometimes I write a line of code and it just doesn't work. And I have to go figure out why it doesn't work. What? What? Why you say? I feel like it's like it's weird. It's weird how they're talking. I would cut that out. I would say, I'd probably sit there and be like, hey man, you don't need to talk like you're talking to a first grader who just found out that computers run on software. Like, you don't need to talk like that. That's strange.
Assumptions that there's limitations in certain aspects and there's other ways that actually.
Maybe they just picked the wrong guy to talk about it too. I don't know. Maybe he's not that dumb and he's just actually seriously trying to dumb it down.
It's more fun because you play the game and you realize, you know what? It's more fun throwing these rocks at this robot, or it's more fun, you know, jumping. And that, I think, comes from playing the game and just playing.
Yeah, you gotta play the game to know if it's fun. I
Around
mean, why does it need to be
with
said?
what you created.
No, it's strange.
And allowing that to express itself
Yeah,
in
videos.
the game's creation, I think that's when you can actually do new, meaningful things.
The way we developed our game by, you know, people put things in there and we feel it out together and we change what's wrong together worked well when we were a smaller team and met each other all the time. But then it just didn't work well once we were separated through the pandemic.
Behind the scenes, Pioneer was struggling to find its identity. The pandemic was partly to blame. Problem solving is much more challenging with teams spread apart. But more worryingly, the various departments were
I gotta
is
look
much
at this
more
one again because I
struggling
need
to
to
find
I
its
need to look at
identity.
both of these individually. I want to see both these.
Behind the scenes, Pioneer was struggling to find its
That's a really
identity.
silly
The pandemic
design,
was
by the way.
partly
I
to
think that's-
blame.
that
Problem
seems
solving
looks
is
really
much
silly
more
to me.
challenging with teams spread
Grappling
apart.
hook?
But
Okay.
more worrying partly.
What's on the other
Behind
side?
the scenes, Pioneer was struggling to find its identity.
Wow.
The pandemic was partly to blame. Problem solving
And those
is
guys
much
are
more
rotating
challenging
really
with
fast.
teams spread apart. But more worryingly, the various
Okay.
departments were beginning to drift with each milestone. Communication was challenging remotely, and as a result, the game was beginning to feel less cohesive. More worryingly,
Engine
the
Crash
moments
one's
that
so
made
weird.
the game feel special, when all the players got together in the center of the map to destroy a large machine, were difficult to replicate. So in order to fix this, the team entered a 6-month phase in which they would try and distill this PvE experience into something that would deliver satisfying rounds more consistently. This phase was known
That was neat.
internally as the pivot.
If I remember correctly, we had actually reduced the game.
The pivot. It's like saying, with the game finally near completion, we had to publish the release date. The release date. The pivot. We did our playtests. We developed a lot of the mechanics, and we realized some of these aren't working. Let's, you know, rework it a bit. That's... I'm sure 0 games have been developed without like a mid development like correction or something because they realized the problem was too hard, or something that they thought was going to be fun just wasn't fun once they actually played it.
Point where I say, okay, we need to make this one part fun. And if we can make this part fun, then we can replicate it, right? Even though we had this huge world, we're just using a small portion of it. And my first task was the moment I realized we were very ambitious, which was, Kaio, can you put a timeline?
Is there some tool that produces these environments? Because Death Stranding 2 has like really crazy looking, like really absurd detail in the environment. Halo's, I think from what I saw, they didn't do any gameplay. They just made environments to show that they can make something that looks nice. Is there some like new software for this? One of Unreal, I think the demo for Nanite, Unreal Engine's Nanite, had this like insanely detailed environment, and I'm like, how did you do that? I mean, first of all, cool that you can have that many triangles on your mesh. Second of all, why do you need so many at all? And third, how did you get so many triangles? Like, where did that come from? How are they? I mean, in honestly, to me, even if you had every asset in a pack and all you had to do was click and drag it, I feel like that process is still so ridiculous that people can't make that. This screenshot would be like weeks and weeks of work just to get this. I feel like what, even if they had every asset already done from like download the pack and start camera setup, start the timer, replicate that, would take you weeks, I feel like. Not even in motion, the camera doesn't even turn around anywhere, like literally everything that's on screen, but they do more than that. How do they do that?
To deliver this game, right, in 2020. And I said, well, from what
I mean, it must, like, I guess it is just procedural, right?
To deliver this
you know,
game,
we jump out
right,
here.
in 2020.
Maybe there's a couple assets manually placed, but maybe like 90% of this is I draw a spline, I draw like a polygon shape, and then boom, terrain appears. And I have some like parameters. And it just seems crazy to me.
Well,
also, I don't even think the real world looks this detailed. I don't think even the real world looks like this.
From what I can see here, did all
that
the
looks
estimates,
it looks
talk to the whole team, understand the whole scope of it. I was like, okay, I think the best we can do is like we need around 2 years. And the answer was no way. We have 6 months. How can we make a plan that fits 6 months? And I remember even the name of the presentation was called Hail Mary Plan. And we had a plan for trying to get something out there in 6 months.
At that time, it was in a state where we were looking at trying to...
Are they gonna say anything that they did? Or like, serious, like, I mean, the comments, man, what is... There's no way. Dude, they are fooling people so much. Oh. This just really sounds like, oh, it's so difficult, it's so hard, it's so difficult, it's so hard, it's so difficult, it's so hard. We're making a game, it's so hard, it's so difficult. We have a time limit, oh my god, it's so difficult, it's so hard. Stretched out to 30 minutes. Like the same line over and over, stretched out to 30 minutes. I would love to see anything technical about what they've done. Okay. Well, that's unfortunate. the most technical thing that they have was like that 5-second clip of their game running at 10 FPS, and there's robots walking around, robot agents walking around training how to walk. That's like as technical as it got. Actually, I think so far the only mention of anything of anyone doing any work, by the way, was this girl saying she did the was it her? I'm thinking it was her. The only one who said that they actually did any work was her saying that she made the panels pop off when you shot the robot. Like, what a waste of your time. You're welcome. You should have wished I drowned. No. Because, see, watching this will help me to avoid talking at all like this if I ever do something like this. Can I say like this 3 times in the same sentence? Okay. Well, I'll be back. That was that. I mean, I'm honestly probably going to watch that on my own time. And if there's anything really nice, then I'll bring it up later. But that's just kind of crazy. That's kind of crazy. This is the one who said something sucked. Well, they said, instead of saying like blow the panels off, shoot the panels off, blast the panels off, they said suck off the panels. It's just weird. It's just a weird way to say that. Figuring out how to suck off the panels or something is what they said. All right, I'll be back. I'm back. I mean, also like designer, artist. I mean, there's not, I'm sure there's not a single person whose title in here is programmer, developer. Director. Who is this guy in the middle, actually? Is it producer? Is this producer?
Automatically say that.
Producer. He doesn't know what he's talking. Producer talking about how he learned that sometimes you have to play the game to know that it's fun. That's crazy. Okay, I didn't see his title. He actually doesn't know it. What? Dude. Oh my god. He is literally not writing a single line of code. He looks at a spreadsheet and says, okay, here's your budget, or no, less money.
The way that we want to.
Is there anyone in here that's not designer, director, executive,
had a lot of internal
director? Is there one guy? No, there's just not. They put his card back up because I don't know, but maybe they think he forgot who he was. At least this one has like 100 likes. Shill. Yeah, I'll give that a comment. Like, that's a shill comment right there. Not just a corporate shell. Every one of these people are corporate. They're all corporate. This is all corporate. Wait a second. Hang on. When did he show up? Wait. Wait a second.
Was a game about exploring and be sort of imagined when.
Oh, there he is. Okay. Audio director. I will say there's a bit of a difference when it comes to audio. At least in that case, you probably are actually doing work. I'm sure he's not sitting there saying, with his headphones on all day, saying, yeah, that sounds good, or no, I don't like how that sounds. I mean, because, you know, listen to it right now. The music for Halo was made by the directors, but there's like 2 of them. They composed it. It does say audio director though, which leads me more to think he might have more say in how to balance the master channel than he does in what things actually sound like. Perhaps even saying, we need a bigger boom. It's not an audio designer. It's an audio, it's not a sound designer, it's the audio director, right? Maybe it's not quite so much. I was honestly thinking for a second that they just put this guy on here and they did not give him a card title.
And just the way the game was played world building it. The game we're making now was the game I sort of imagined when we started building.
Yeah. When opening Unreal Engine, isn't that enough for you? I would actually like to see a proper analysis of this video, but I think literally the only person who talked about any work that they actually did was that one girl saying that she made the panels pop off the robots when you shoot them. Which is just... What was their title? If I can find where they first show up. I don't think it was this late, right? They were kind of early, right? I didn't look at their titles yet.
Dog?
You know, if
Of experience.
No, they showed up here, but like I don't know when they appeared.
That's been
Home is documenting the story, but exactly experience from us. The next EE rises. 3 parts of archaeology passed over the year. More Kickstarter.
How did the games?
Surely they're at least on screen for more than 5
That's
seconds, right? Like there's not a chance I can skip over it.
Part of the we quick that we rules.
A big try and see.
Yeah, I thought they were like really early,
Seeing
like in the
we
first couple of
won it,
minutes.
By the way.
The game in the things. I think the idea also. I mean, the machine game.
Those are the only people who haven't seen the title of yet.
Studio.
I want to know.
IDA activate.
I think the game we were able to think fun all against the in just from a pure
ambitious session-based obstacles. So
3 and already
What?
have at the moment
They were this late?
that we have there.
I watched half this video,
All harder than
I don't know. It was far.
and I thought they were like right
years ahead,
immediately
which
there.
aspect is very.
what you for our trade agents just open.
All right, they must have shown up for like a second
mistake, bunch of
before.
Do you remember? I remember
Yeah,
one of the,
people to
because
Mars, you will crash a bunch of rockets. We crashed a bunch of rockets.
I remember one of the earliest things I worked on was the dog. Do you remember like the 4?
Oh, she said that she did 2 things.
Thing that ran
Technical designer, okay. Technical designer. Okay, when she says worked on, does that mean she worked on it, or she tells someone else to work on it? That's the question. They developed the game, the park. They showed that park more than the devs. I mean, it's just documentary stuff, really. They're really playing this up like a documentary. Technical designer. I mean, I guess the idea is the technical designer is supposed to have actually written code before. So when a non-technical designer asks them, "Can you do this?" they get to nod their head and say yes, and then they get to figure out how to do it. Is what that says to me. Love their tattoo. This? Wait, which one? There's 3 tattoos. I can't even tell what's on their arm. I see clouds. It's like a nature thing. Ah, technical. I mean, these are the 2 most technical people in the entire thing. Maybe probably the audio directors, possibly even more technical than they are, but she is also the only one to say what work she's even done. Everyone else is saying, it was really hard to navigate the Word document. I really couldn't quite figure out the lore. The executive producer of the game learns that making a game requires playtesting to find out if it's fun. That's nuts. That's crazy. I feel like you can't be an executive producer for a game unless you know that, at least. Hey, ChatGPT. I'm the executive producer for Arc Raiders. What should I know? What should I know about game development? Playtesting is a very important... I'm not going to get over that. I'm not going to forget that, man. The executive producer talking about playtesting to find out that the game is fun. That's crazy. Alright, what have I got? I think I've written something. I did that. I think this is an improvement. Instead of doing the ground plane to the body, I do the body plane to the ground. Which, now that I say it like that, why is that different? I mean, I guess it's different because if the plane rises, then I'm checking this plane to this point. And instead, if the body tilts, I'm checking this point to this plane, which means if the leg is far away, you know, that tilt allows it to go further. But if we're measuring from the ground point to from the ground plane, then that point is always like, you know, attached really close to the body. I mean, this is actually what I really said, was I wanted to effectively project that attachment point out, which if I make the body, if I make the plane be the down vector of, or just the opposite, which is just, you know, just to fix the directions, really. So it'd still be the same number. It'd be positive when it's above, which is, you know, the distance to it. And it'd be negative when it's above the body. Yeah. I mean, that's that. I think that's what I said, and I think this looks better. The rest points are pretty much like spot on where the legs actually are, which is what I would have expected to see. Definitely improved. It feels really warm. It says 73, and I feel like it's suddenly way warmer than that. That's some really, really high contrast light. And your face deep learning animation. I mean, that's just the thing. Like, you can code that. You can write the code. Leave machine learning to training things to do difficult activities that you can't even conceptualize. Or just to see, can, you know, more like an experiment of neural networks themselves. Like, can a neural network learn this thing? Spoiler, a neural network can learn anything. If it's big enough. But I don't know. If you're making real robots, I'll say that. If you're trying to put a real, like Boston Dynamics, put a real chunk of metal in the real world that is supposed to handle the human environment, then do as much training as you can. Because there's no way you can write every edge case. If you're writing a robot to go in a controlled digital world where you can do a lot of cheating and take a lot of shortcuts that are non-physical, do that. There's no need to, and like I said, doing that method puts a huge limit on how many of them you can have in the game. It seems like they're limited to one. The boss robot, there's one boss robot, and that's all you can have because it is computationally expensive. That clip where they had like 4 of them in the world walking around for training, as far as I'm aware, real-time training is not any slower than actual runtime, as far as I'm aware, because you just give it some random weights and biases and let the algorithm compute. I don't know if you know how to do it already and you're on a budget. It's computationally expensive. The training is really expensive. The neural network that produces it, during the expensive step of training is post experiment. You can think of the training as being the experiment and then the training phase. That training phase is the expensive part. The experiment part runs at the same speed as it will run in game. So when they had like 3 or 4 of them in the same world and it was chugging at like 10 FPS on what I'm assuming is a really good computer, to me that says that their AI, their neural network is just really inefficient. I mean, ideally you would throw in you would do more than 1 robot at a time for training, right? During your experiment. It's scripted or backed. I mean, I guess there's some optimization, perhaps. Like maybe their network model is inefficient during training or early in training, and then they made it more efficient later. But it's effectively like, I wrote 10 lines of code, I hit play. That's the experiment. The training is then a huge process afterwards that's really computationally expensive to, you know, do the learning. Sorry. Training is like experiment and learning. The learning is the expensive part. The experiment runs at the same, should run exactly the same as if it was running, as if you were running the final product in game. Maybe their network is just inefficient. Maybe they learned later on that they had too many inputs and they could just totally drop some inputs. And I think the real problem with that is you have to, if I want a 6-leg 3-segment creature, I have to train that creature. If I want to move any of those legs, I have to retrain the creature. Here, I want different legs in different positions, I can just move them. Nothing stops me. It should behave the exact same way. If I want 4 legs, alright, I just have 4 legs and my code stays the same. Maybe I need to tweak a few parameters, but I'm trying to write it as if I don't need to do any tweaking. The script is generic and can handle any legs in any, I say any configuration. The legs should be in pairs. You have a left and a right leg every time. But yeah, that's, I mean, I don't know, maybe there is like a really big optimization you can do. Like you can totally cut out the graph entirely and you just have some kind of like super linear matrix or whatever it would run with. Or I don't know, maybe they made it so simple that they actually could just straight up look at, convert the network into pure lines of code, right? Have input ABC and then have output right directly to them, and then in the middle is like 10 multiplications or something with some constants. But I feel like there's not much, you don't get very much. And it's definitely still limited. Like you definitely still get limited. I can't imagine that effectively a graph network is more efficient than writing it yourself. And more resilient to change. Like I said, you know, the network would train on the assumption that every leg is exactly the same distance from the body in the right place. Like if I go in there as the artist and I say, I don't like how far forward this leg is. I want this leg to be slightly longer. I want to add another segment. I want to remove a segment from the leg. And it's like, oh, okay. Well, we got to go train it again. You'll be able to play with it in game tomorrow morning. Maybe. Yeah. Okay. Time to get on with it. Right, this was good, right? I need to, I guess literally just this line change. 2 lines changed. Yep. And then also it's like, I notice something weird happens in this situation. I can go find the lines of code that make that happen. If I discover after training that there's some new situation that it hasn't been in yet, and it behaves really weird, then I'm like, well, tough luck. I have to find some way to hack in a fix to a neural network, which is, you know, I guess just like fundamentally impossible. Or you throw that situation into the training and then you let it train and you tell it what you wanted it to do. Just those lines. Improve. Here's the body attachment plane distance. Gives a much better result. And you can get exactly what you want. Literally exactly. Like some people might forget that about computers sometimes. You can write it to do exactly what you want. Notice something weird, you can fix that. That was actually kind of funny. Do that again. I don't know why this is funny to me. I think I'm just brushing past it. Okay. Though I do kind of want to see what this is. This looks weird when it starts. Is it like pause? Wait, how can I make the game pause? I think I can just do, hang on. Input manager.pause next tick, is that right? I can set that to true. I can also just write pause. That's actually the same thing. Yeah, that makes sense. That's probably what I should do if I want to pause the game when I launch it. Later on after training, it's scripted or back. Oh, I already read that. Never mind. Go over here. What happens to you? Why do you do this? Yeah, what is this? This is weird. There's some instability happening here. Okay, I think this is probably just a case where anti-gravity is not proper. Okay, let me see if I can fix this. This just looks so blown out and contrasted. Alright, that's better. Cool. Okay, so what the other one did was it would draw a polygon and it would map the center of mass to the closest point on that polygon, and it would draw a vector. Well, really what I should do is probably just draw a vector straight up and apply anti-gravity in that direction. Because what I should see happen is this thing spawns in and it drops like that. That's what I should see. It should just go boop. But what I see instead is this like crazy instability thing happening. Which I mean, I don't know what, I really don't understand why it's doing that. Okay, let me see if I can track exactly where that happens. It shouldn't be rotation. I don't think leg offsets, but I guess I'll find out. So, let me take the breakpoint off for now. So I'll let this run a little bit until it gets really, really bad. And then, okay, so about here it's getting really bad. Put a breakpoint there. Okay, I have to like, I can't grab it because the mouse is like insisting on staying underneath. Okay, I can just do that. All right, so what's our state? That is a crazy high angular velocity. What? Okay. That shouldn't change angular velocity at all. The solve rotation changed that value. It changed it a little bit, which is weird. Does leg offset change that? Yeah, okay. So I need like a pass line here just so I can have it run. Yeah, okay. All right, it's really unstable right now. So 0.805. Solve rotation changes that, which I don't really like. I mean, whatever. I'm expecting leg offsets probably does something dramatic to this. Okay, so yeah, something is wrong in solve leg offsets. It's like... It's just unstable. It's like wildly unstable. Alright. I'll run through and see exactly what line is the problem then. I guess I can actually just put it in here. Okay, so our state is negative 0.751. I guess I can probably look through all the legs and see what their offsets are set to. That one's not grounded. Only grounded legs count. I scrolled past it. Grounded. Ground offset. It's like barely underneath it. Right, it's barely underneath it. This one shouldn't be grounded. It's not. This one is... How am I not seeing it? Barely in the ground. Or barely too low. This one should. Yep. Same thing. They're all like the same value. But what looks like is going to happen is after this calls, it's going to flip it. This sign is going to flip. It's going to go from negative 0.751 to positive 0.7. Or it's actually going to go to like positive 0.755 or something. Something slightly higher. Okay, shared mass. So we have 3 legs. Those 3 legs can fully support the mass. So does that make sense? 64 divided by 3, 21 point. Yep, that value makes sense. Okay, then we go through each grounded leg. And we compute the real offset. So it currently thinks, yeah, we're just barely below it. And then does this change that? It did not change it. So what is the average displacement? The average displacement should be... Actually, the average displacement is the same on all of them. So I should see like 8 something. Where is it? Probably up here. I think it's just where I scrolled past it. Grounded leg average displacement. I think I saw like 0.894. That doesn't make sense. I feel like that's not correct. If this one's displacement was... Yeah, that doesn't make sense. That value is not right. I don't think that value is right. Right, continue. Okay. I feel like this is not correct. because the offset should, in that case, the offset should have been 0.9, and each leg offset was like 0.894. And the average said 0.14. So that didn't make any sense. That was too much. Maybe because I was dividing it by the int, somehow it didn't come out right. Leg ground offset minus body height offset. Is it the same calculation here? Leg ground offset, body height offset. Yeah, because this one came out to like 0.06, 0.006 was the displacement. And it said, oh yeah, your average displacement is 0.14. Definitely not correct. It was like 0.014 when the real was like 0.006. Okay, so this leg's offset is 0.914, so it's slightly above the ground. So it's too high. So it's 0.194 or 0.014 should be the result here. So the average should go to 0.014. I see 0.014. Let continue. Each of these legs should be grounded, and it should be these legs. 909. So that's 0.009. And this one would be slightly too low. Okay, so the average actually kind of comes out to being probably slightly high, if I had to guess. The average displacement is slightly high. Okay, so this case, we're on, it said counter is 3. I'm assuming that literally means 3. So that one added 0.09, or 0.009. So I should see 0.023, thereabout. .023. And then I should still have one more leg that's grounded, so I should be okay to hit continue. We're seeing the same frame. This one should be adding wait, what? That's a different value. Is that really what I... Huh? What? Am I misremembering? That doesn't feel like the value that it was. Oh, this one. Wrong one. 914. 9... No, and then I said, and this one is slightly in the ground. One of these was negative. What? No, one of these was negative. One of these was negative. It was too low. Okay, so here's what I'm going to do. Here. Before we do any leg updates, I'm going to look at every leg and write down the values of each leg. Because that is so suspicious. I could swear I saw that one of these should have read in the ground, and I said it looks like the average will be slightly high. I could have sworn. That one's infinity. 893. I'm writing these down. Which should equal to like negative 0.007. I expect that one to be infinity, and this one I'll find out. This should be infinity, and this one I'll find out. Infinity 3876. Which would come out to 24. Is that correct? I believe so. 4 should be infinity. Gosh, if I could like remember where it is. Infinity 5893. And I would expect these two in the middle to be the exact same. Or these two on the edges to be the exact same because they are the body is perfectly aligned and it's just doing this left-right spin. Alright, those are the values. I'll do print just so I get it to actually look nice. Okay. So now what I'm going to do is I'm going to click here. I'm going to hit continue. Counter position 1. So I expect to see it adding 0.007 to this. I expect that it is currently 0. Is legs on here twice? No, it's just whatever. Where's the thing? Oh, there it is. 0.007. My body height offset is 0.9. This leg's ground offset. Oh. Right. Okay. No, I understand. I am updating it, which means I'm redrawing the raycast, so it's actually different. That is correct. It should be different. Okay, my bad. So yeah, 0.014. That's correct. The leg offset is now 909, so I should see adding 09, which will become 23. Okay. Oh, it is the average absolute displacement, not the average signed displacement as well. So this one is same number as the other one, which is what I would want to see. 2, 3 plus 1, 4, 37. 37. Okay, now this value, I expect it to become about 1.2. 0.012. 0.012. Okay. The ground normal is currently 3. It'll be divided by 3, and it'll be normalized already. Okay. So those are all correct. Now I want to see inside of solve like offsets. Shared mass should be 21. All their offsets are set. And then here's where I'm computing spring forces. First leg is not grounded, second leg is. So this should be like 0.14, 0.14, and then it'll be limited to 1.2. So I should see it's chopped down to 0.012. Cool. Now the speed. The leg normal dot the leg ground velocity, which is 0, which is not correct. Why does it think the ground... That's probably it. It's technically not doing any damping at all, so it just fluctuates wildly like that. Okay, that would make sense. If speed is... what? Leg ground velocity? Huh? Did I do this wrong? Wait, what? I hovered over it and it said current value is 0. Yeah, okay. It's, okay. I think it's showing me the current value, perhaps, of crawler character and not of the leg. How does the leg know that it's moving this fast? This is really fast. Why is the leg moving this fast? Where does it get that speed from? I think what it should be doing is calculating state, get velocity at local position, which I actually think this was right. We're getting the halfway point between the attachment and the ground point as the leg velocity. Really? And this just becomes 0. Oh wait, it's actually not. It actually is pulling back, right? Yeah, positive on the X, negative on the Z. Yeah, because if it's relative to the ground, you can look at it. This is the front. That's this leg in the front here. This disc is rotating from the way we're looking at it. It's rotating counterclockwise. So that means it's as if the leg is coming forward. Or I guess if I were to do my fingers relative to the actual screen, the leg is going that way, right? It's as if the leg is moving forward that way along the ground. And that's what I see. Negative on the... Yeah, right. Negative on the Z, positive on the X. Negative on the Z, it's actually more positive on the X, which is strange. I would think that'd be more Z than X. And it's also moving up relative to the ground, which is strange. But okay. Moving up relative to the ground. Oh, right. Yeah. Script. Okay. Okay, so a computer spring force and a damp force. The spring force is negative, which means relative to the ground normal, which means it wants to move into the ground? No, that doesn't seem right. Offset is... Oh yeah, it does, yeah, so it wants to pull into the ground. Okay, then damping is really high. So the result of this is actually going to push really hard against the ground. Have I done something bad? No, the legs all compute their thing before making any state changes. Yeah. And then in here, the state changes happen. But it's a problem because this totally changes the direction that the spring is moving in, is the real problem. This is going to completely change. And I mean, that's at least what I saw. That's what I saw happen. Angular velocity is 0.869. After I run through the step, that angular velocity will be much, much higher. Or more negative. So currently it's going this way, and now it's going to like flick back. Hey, R1. I mean, I guess I can look at what this does to the state as it changes. Because in my mind, this should go back to 0. Okay, it's gone way further than that. Okay. It is overcorrecting really badly. What is my damping? 2.2, 2.5. How's the beverage? It's good. Coke Zero Cherry. Or Cherry Coke Zero. Hope the behavior isn't giving you that much of a headache. I saw yesterday you were figuring out something related to the walls and gravity. I got it climbing up the wall now. It can climb up the wall. And it looks pretty nice. But now I'm just saying there's something odd. The spring forces aren't right. It's like rebounding, essentially. Because it was at this Z value, was at 0.8 something, and now it's at 0.3 after one leg has processed, which is definitely not right. So I don't know, maybe I just have too much. Maybe this is just too much. Maybe it's wrong to limit the offset like that. Because that one was going to have a higher offset. At least a slightly higher offset. Wait, is my speed wrong? Hang on, what? Leg, hang on, leg velocity? What was the leg velocity? We're moving up, and we're already above it. So yeah, it's trying to reduce... Well, I mean, it should... Alright, I don't know, let me see one more. Has something to do with center of gravity. Well, I'm applying the force on the attachment point of the leg. It's just weird because what I see happen is that when it's stationary here, it does this every single frame, right? So one frame it's static, next frame it's a little bit tilted, next frame it's tilted a little bit more but in the other direction, and then it keeps doing this until all the legs are in contact, and then it stabilizes very quickly. But for a moment there, it's wildly unstable. So it just means that I'm missing something physical here. There's some like physical limit that I'm doing the wrong calculation. Because I'm pretty sure if you set real springs on a inclined surface, they're not going to vibrate back and forth until one side of the spring is, till the other springs hit the ground, right? That's just, like, there's a mistake here. Is that one specific leg? It's all legs. I can show you what I'm looking at. I'm looking at this. So on this frame, it just went back to being steady, and then it's going to do this, and then it's just kind of freak out. It's just because these legs are touching and these legs aren't, but I'm looking at the spring forces, and it looks like the spring forces are way too powerful, is my thinking. But I thought they shouldn't be that way because that's the spring force I'm using for myself, and it's okay. It's also possible that just adding them together isn't quite right. Because at least in my case, I limit this to being 0. But I need to allow this value to be negative so that it can pull itself into the ground, which is necessary. This is just calculated like something kind of insane. The speed should be the same, right? 0.8. I mean, yeah, that's just crazy. That's a meter per second into the ground. Or off the ground. It thinks it's moving a meter per second off the ground right now. This one's calculated at even higher speed. Which I guess makes sense because if it's, you know, if we're dragging the body out, if we're at the halfway point, this leg is further away. Yeah, I mean, look at that. That's just kind of crazy. It's more that this somehow doesn't stabilize. The speed being positive means we're moving off, and then I set that to be negative. Let me think about that. Should the speed be negative there? All the legs moving independently? Yeah, in a way. They're all attached to the body. The speed is calculated from the body and its rotation. But it is that the spring is unstable. It's adding energy to the system when it shouldn't be able to add energy. How does it add energy to the system? Could it be the position of said leg or the offset? Huh? Watch him going up the wall. This isn't about a wall. This is just standing on the ground. If half the legs are in contact with the ground and the other half aren't, it's like freaking out and accelerating dramatically. Do I need to update the speed every time I move a leg? I feel like I shouldn't have to do that. Because if I think about it, it is 3 springs hitting in the same place. They all have their own shared mass. Which that should be correct. Like if they were all reacting to like the full mass of the body, then yeah, that's probably a problem. But they're all getting a split of it. Physical plane of free because nothing sound. No, it is in contact with the ground. These blue arrows represent ground contact. And they can only apply forces when they are in contact with the ground. It's essentially taking the body, the distance between, like if you think of a plane here drawn just across the body, across the middle of the body. Draw a line up until it hits that plane, or not up, but like draw a line to the nearest point on that plane. This is the body offset. And it treats that like it's a spring. So if that point is too close to the ground, it wants to push away. If it's too far, it wants to pull in. I mean, I don't think updating the velocity is necessary, but maybe it is. Maybe I do need to update the velocity of a leg after one leg updates. This might be a contact problem. Suddenly the velocity develop. Oh, why not? I mean, look. It's moving a meter, 1.2 meters per second off the ground, and that's happening in a single tick. The game has been running for like 5 ticks, and suddenly the body is like accelerating off the ground at a meter per second. That's kind of insane to me. And the damp force is massive. This is a huge force. This is an order of magnitude greater than the spring force, and what happens is that 1 second I'm going off the ground at a meter per second, the next second I'm going into the ground at 2 meters per second. Right? Like if I just hit continue and skip over this frame. and go through to the next one. So last frame, we were going at 1.2 away from the ground, off the ground, into the sky. And now we're going, okay, I guess it didn't increase this time, but now we're going 0.9 meters per second into the ground. I mean, I can update the speed because changing the state here does change the velocity. I'll try that. I don't like it because it doesn't seem right, but I guess in the sense that I have multiple springs acting at once, it probably makes sense to just recalculate the speed. So here's what I'll do. I'll just remember this value. And then I'll grab this one every time. State that transform, like that attachment point, like ground point. I don't see any instability. Though it doesn't fall, because technically these legs are enough to keep it off the ground. But if I give it a push, there it goes. Though it doesn't bob anymore. Oh, maybe it kind of did. I mean, I can definitely reduce the stiffness of the springs. I also think it probably makes sense to have a limit. Right now my limit is like 1,000,000 force, which is probably insane. I think of force as classic science formula. Force is mass times acceleration. I could say limit it to an acceleration of 12 meters per second for each leg, effectively. I don't think I'm gonna worry about that. All right, but that's better, I think. This is managed here. No, it's managed here. No. Where is this? Oh, there it is. Let's try 2 and 1.8. And then I guess I have to right click on this and click reset. I'll just close it. I guess I have to reset that one too because it's dumb. Okay. Right. We're still pausing at the start. Stop pausing. What if you stand on this thing? Well, that's actually not even going to push you. Actually, I want to see what happens if it does this. Quick. Oh, it's too heavy. Oh, well, it's actually pulling itself down, so it's actually working against that spring. So that makes sense. Alright, come over here. Move. I want to see it start bobbing. I guess, okay, I mean, I guess it is the case where the anti-gravity would totally stop it from dropping. And that's probably why I saw it dropping, because it was super... Yeah, I mean, I guess if I'm changing the velocity, then I should update the springs to account for that change of velocity that's happening. But I guess I just thought that I shouldn't really need to do that. But I'm sure there's some kind of math where it makes sense. Let's go lower. Yeah, I did unfortunately lose the bobbing, but I guess the bobbing was caused by a bug. And it wasn't actually correct. Which way are you trying to rotate right now? Yeah, when the normals are like that, it really struggles. The normals have to be like vertical or else it can't figure it out. When it rotates, it kind of does it. A little bit. I mean, but I think that there you put that in there. Oh, well. Well, those also didn't even update. Pen and paper. Leg? That leg normal is weird. It does not like that. It almost for a second looked like it was actually spinning out because it was on the moving platform. Yeah. That's probably where limiting how much force it can apply will prevent it from being able to launch itself off the ground like that. What if this is less than 1? I mean, it still holds itself up. Maybe what I need to say instead is that for each leg normal that's not well aligned with the ground, then I need to reduce gravity's effect. But if it's like totally aligned with gravity, vertical or right side up or upside down, then it should only rely on the springs to attach itself. It's when it's sideways. Springs and velocity, never thought those two would go together. Well, I mean, that's how most springs are done. At least in a physics calculation. You have a spring force that depends on how much it is compressed, and then you have a damping force that depends on its speed. Or I guess specifically its velocity in the spring direction, which just means the speed. Yeah, I guess I meant to update the velocity for the future springs whenever one acts. All right, I don't need to tweak that though. I don't need to tweak that. I can make that a future thing. Okay, so what was that? What was that problem? Yeah, that was like a weird instability thing that I noticed. So that's fixed. I don't know why it thinks these legs are on the ground. They're definitely not on the ground. It looks good enough. Yeah, I'll show you walking up the wall. It does walk up the wall right now. It should still walk up the wall. I guess I'll find out. Face this way, please. Go. Oh, it's doing bobbing now. It's bobbing a little bit. Yeah, it just goes right up the wall like no issue. Stopping, it can't figure its legs out. If any normals are different, it really kind of can't handle that. I'm not sure why. It's actually getting there. It's kind of getting there. Okay, it's not. It's probably stuck in a loop for a while. But yeah, it does pretty well. You know what I should do? I should just make like a vertical wall here and see if it... Wait. Yeah, hang on. Hang on. Is this big ramp? No. Slope wall? Slope wall. Slope cut. CSG box. Alright. Box. And then I'm gonna do duplicate that. Move it below that one. Why can't I translate this one? I would like to translate this. Did I turn off like the transform gizmo? Like what's happening here? Oh, it's locked. That would make sense. Okay. It needs to go up slightly. There we go. Yeah, it's probably good enough. Okay. Let's send it fully upside down. I don't know. I think its pathing is probably not going to be very good. I'm probably going to have to like really convince it to walk in the correct direction. Okay. Go like halfway up. All right, go further up. All right, go right there. It can do it. It can crawl all the way around. All right, now what do you think about... What if I did this? What is he gonna try? I am shocked. How does it do that? There's no pathfinding. It literally just knows the point. It literally just knows a point, where it is, and where I told it to go. What do you think? I'm assuming here it's going to walk straight into me. Yeah. Okay. That's what I thought was going to happen. Interesting. Okay, so... Come over here. What if I... told you... that point? It might mess up because it might try to turn around in the middle here. How? How? I don't get it. There's got to be some kind of just way that the forward vector happens to always point roughly uphill. I'm kind of surprised that I was able to walk up that, despite the very vague instructions. I'm sure if I tell it over here, it'll probably just walk straight off. So, come over this way. Yeah, it's just gonna walk off. I want to see that though. It should walk off. It might stop itself before it goes off. Okay, nope. It just... And it's through the floor. Okay. Interesting. Interesting. Continuous collision detection. Let me turn that one on. Let me turn on continuous collision detection there. That was funny. Okay. I am pretty happy that it could be that resilient to navigation. Like, in theory, this would all be a nav mesh. So if I put a point up there, it would trace a straight line up there. But I mean, as long as it's like kind of in the right direction. Like I can click up here and it will just... Okay, well, yeah, it has to be on the ramp, at least a little bit. So if I tell it there, it can figure that out. Amazing that it's moving without any line or direction. Yeah. I am pleasantly surprised that it is that it can just do that. That leg is just dragging forever. I really need a reticle badly. Yeah, I'm assuming that any point I give it kind of has to be at least a little bit on the curve. So if I tell it here, it should get on the curve and then start saying, oh, I can go forward, like down a little bit, you know? And then it will continue crawling all the way down. Okay, it's got to do a correction here because its one leg is really far off. Okay, it's just gonna leave that leg forever detached, I guess. Until it comes back. Yeah, but it just cannot handle strange normals on the surface still. Wow, that's awesome. That's awesome. Okay. I did mess with the springs, but I don't know if I really needed to do that. They can be a lot less for sure. Alright, but I'm gonna send this. This is definitely a fix of some weird instability, which it just seems like since I know I'm changing the velocity, I may as well update the velocity of the spring because then it will be more accurate for damping. Like, it's not really... It still bugs me a little bit that it doesn't work unless I do that. Well, I say it doesn't work. It was working when it was on the ground. But if any of its legs weren't on the ground, it couldn't quite handle that. All right, I'm gonna. Should I type in values? I don't know. Wait, why is that one? No. Okay, hang on. I'm assuming what happens there when it does that weird thing is like a leg hits a weird normal. Is my thinking. Yeah. Alright, but that looks cool. Okay. And then deleting... Well, I guess I don't want to delete that line. I'm going to leave that line. Because I'm probably going to keep coming back to that. Nah, I'm going to delete the line. What changed in here? Oh, I turned that on. Yeah, okay. Yeah, just set the whole thing. I modified that box, so I'll do that. Yeah, I'm gonna see if I can fix that number. I was not able to fix the number. Okay. Oh well. Okay. Improve leg springs with velocity updates. Recalculate body velocity during leg spring. Improves stability. Yeah, just improves stability. Since damping may I still don't understand that. It still is weird to me. I mean, I guess all that spring stuff is not like, it's not a shared mass. It's one spring on one mass. But I guess because it's shared, it just, you get the wrong results, right? Because one spring updates and it says, all right, let's accelerate here. The next spring updates and says, all right, like we still have a high velocity, so let's accelerate more. And then we accelerate even more. Okay. Yep. Okay. I really wonder if I should change the raycasts out to shapecasts. That would give me better normals. It would. And then I think I should really have anti-gravity apply to the best position between these legs. Because really in this case, when these three legs are first in contact, we just say, oh yeah, the spider can hold itself in that position. That doesn't make any sense. Because its point of force is essentially along these three legs. Or along these three attachment points. So really the body would... That part of the body would stay stationary, but the other part should fall down. What do you think about this, by the way? Oh. Okay. Interesting. Interesting. Yeah, I don't know. Can you go up this yet? No, you just walk through it still. Okay. So I wonder if this case I probably... Ooh. Yeah. Okay. Alright. I think I need to limit... I'm gonna go ahead and limit the springs. Well, damn, that was crazy. Yeah. It looks funny, but it probably shouldn't be happening. Final form. That does only happen because it thinks it has some huge offset and it's able to apply this extreme force, which it just shouldn't be able to apply. I think how I should probably do it is that acceleration thing. So I say, I already have the individual stuff here. I should have like a acceleration limit, which you know, in robotics, especially for robotics that are designed to be around humans, you would probably have some limiter, so it can never apply more torque than like essentially would break a person's finger, I guess. Right? That's probably like a good standard. No motor should be able to clamp its parts hard enough to break someone's finger, or like whatever really weak bone in a human body is. Or if they can, if they detect resistance that's too high, then they stop themselves from doing that. But then in my mind, if these are like hacked robots and that safety mechanism is probably disabled, but there is still a limit to what hardware can do. And I would assume that limit is not much higher than offsetting gravity. So yeah, I want to try this. I want to do this. So I would like desired gravity to drop to 0 when it is sideways. This means that my springs have no alignment with any of the legs. None of... Whatever. If I... How can I do this? I think I would calculate it per leg, because each leg has their own normal that they apply, right? This is the force, the ground normal of each leg. So I guess what I could say is I could look at each leg's ground normal. And depending on how unaligned that leg is with the ground, then I can apply up to double a gravity offset, perhaps. That calculation is kind of complicated, I think. Because in this case, I would like there to be no anti-gravity. So I'll even just write this. Okay, the legs are not enough to keep it off the ground anymore, which is kind of what I thought might happen. So let's turn these back up, because there is a certain point at which this can lift it, and there's a point at which it can't lift it. I might have gone too low. How are those not in contact with the ground? Alright, let me move it off of that. Okay, so that's still not enough, which is really interesting. How? Got the increased damping? That doesn't make any sense. Damping shouldn't be force. Is that right? Was this at 2? Was this at 2.4? What was this at? What is mine at? $2.5. But this thing has 4 of those. So I'm surprised it can't negate gravity at this point on its own. Is it because its points are floating in the air? Is that the problem? Does it need to start on the ground? Interesting. Okay, so that's a weird thing I gotta figure out. Alright, now the wobble is back, which is great. That's what I would really like to see wobble. Can you handle this still? I'm not sure what's going on there. Okay. Yeah, it looks great. Okay, so now what I would like, I think, is that... Yeah, how could I calculate this? Because if I have like one leg straight sideways on a wall, then I would want to apply... I guess that in that case, it could only do... Well, I don't know. Because I would read in the first 5 legs, and I would say, yeah, these are all perfectly aligned with the direction of gravity. It's either 1 or -1 or something like that, so I don't need to do any anti-gravity on those. And then I get to that leg and I say, this one is not aligned, so let me apply... I don't know, what would I say there? Would I say, like... a third of anti-gravity? That doesn't seem right from one leg. but it also needs to be perfect. Like if I were to put it on a like 1 degree incline, there needs to be some anti-gravity there to stop it from like sliding essentially backwards is what would happen. It would slowly slide backwards. Okay. Let's say gravity is like 10, and let's say I claim the robot is able to each individual leg. Okay, all legs together could apply 12 meters per second of acceleration off the ground. That's the maximum force that they can apply. And then I guess I'd probably want some kind of readout. Or maybe what I should say is like... I don't know, this is a weird way to think about it. Because what I want to say is both... I could do 12 meters per second of acceleration max for all of my legs. So divide that by 6, it'd be like 2 meters per second max. But then I would also want to say 3 legs is enough for like an effective anti-gravity. 3 legs in contact with the ground is enough. Or in contact with the surface is enough. So how do I make those two meet? Maybe what I say is just have some like slider that's like a percentage, and I say 0.5, 50% of my legs are enough for anti-gravity. And then I would check what gravity is, or maybe I'll just have some constant that says 9.8 meters per second is the effective gravity that they are made for. So divide that by 3. Something a little bit higher than 3 meters per second is what each leg can apply. And then I just go through that. So if I have one leg, it will do... Maybe I do some adding, right? Maybe I count up all the legs that would like to apply some anti-gravity and how much relative they want to apply. So if there's anything that's like straight lateral, it would be 100%. It wants to do full power. So I add all those up. I clamp that between 0 and 1. And then I take that and divide that. Yeah, how does that work? How does that work? If I think about it simply, with the one leg on the wall, it would apply a maximum anti-gravity, right? 2 legs on the wall, they both apply the maximum, no issue. 3 legs on the wall, no issue, they apply the maximum. it gets to a point where once I flip, once I have more legs on the wall than where if they all applied maximum anti-gravity, the body would actually start floating away. Maybe what I do is I would keep a running total of how much gravity I've negated and make sure it doesn't go over that. But then even if that does happen and I have 4 legs on the wall, I would still like each of those 4 legs to be technically applying their own anti-gravity at their positions. Otherwise, I might say the first 3 legs do anti-gravity and that 4th leg is just dangling and kind of doing nothing. Right? I don't want to say that. And it even gets to the point where I have 3 legs sideways on the wall, and then I have that 4th leg on like a 45-degree angle, or like an 80-degree angle. Like, how much of a share of work does it get? Fourth leg is the life of the party. I'm trying to think. How could I do that? How could I split up the work between them proportionally? I might have an idea. Oh, jeez. So legs is going to be an array of cosines, I guess, of cosine angles. So essentially it's just going to be the dot of the leg with the gravity normal and then absolute value of that. So if it's 1, I don't want to do any work. If it's 0, I want to do max work. So my thinking is I start with total work, I go through each leg. Total work is 1 minus L, and then I guess I can do I'm starting really small. Calc work, I'll have 0, a 0. I'll say a 1 leg is perfectly aligned, and then I guess I'll go for the full example of, no, I can make it work with just 4, right? Okay, so in this case, I got 2.2. Wrong way around, I think. I meant to do... Oh, wait. No, yeah, I was thinking about it correctly. Yeah, that's right. It's actually these 3 legs are doing work, so I just wrote my example wrong. What I really wanted to do was a 1, a 1. Oh, geez, come on. A 0 and a 0.2, sure, right, okay. So I got 1.8, okay. So this is 1.8 I guess, units of work that want to be split. And I say 2 legs are capable... Alright, let me do 3. We'll go for 3. I think like 0.707 something is like 45 degrees. So I have 1 at 45 degrees, and then I will have 3 at zeros. Okay. So I get a result of saying I would like to do 3.293 legs worth of work. Which, I mean, you know, looking at it, adds up, right? But then I want to divide that amongst 4 legs, but proportionally. How could I do that proportionally? I don't want to average, right? These legs should all be doing the same amount of work, which an individual leg should be doing more work than this leg. So just like as a rough example, this one might be 0.2, and then these would all be whatever 0.8 divided by 3 is, right? That's essentially what I'm going for. But then this work total can't be more than 3. Or I guess I could say, you know, how much anti-gravity does this equate to? This equates to 1. Right, because I have 3 legs that can... 3 legs would be enough. And then I have like the extra 0.293 of a leg. Okay, so here's my idea. So I calculate the total work. And I guess I say... I mean, yeah, ultimately I'm getting to like some kind of shared work thing. So can I just say like legs? What can I do with an array? Does that work? Is that how you do it? Okay. So I'll make a copy, I guess. Hopefully that actually makes it different. And then I'll go... Wait, I can't remember how arrays work in Python. Can I just do... Yeah, can't do that. Legs resize? Size? Really? All right, hang on a second. Alright. That's just some crazy Python stuff. I didn't expect that. I can't grow a list. I have to append individual elements or provide it a number. That's weird. Okay, whatever. Anyway, back to this. Should be I. Gonna have to call it early. Might as well listen to my body for once. Hope you managed to overcome the logic hurdle. Yeah, thanks. Yeah. Definitely. I'm assuming you're going to sleep. Yeah, definitely try to go to sleep at good times. Okay, so I'm thinking Shardwick I is going to be something like I mean, I guess I can think of it as its relative total, right? So copy that and set likes to this. Usually up till 2 a.m. I'm just yawning every 10 minutes. That isn't a sign, not sure what is. Yeah. Okay, so I do have a total out of 100 now. Did I say out of 100? I meant like out of 1. So if I were to add all these up, I should get 1. See you around? Yeah. See you. Is there... Oh, no. Let me make this return. Yeah, I pretty much won. Okay. In this case, this works if I know that at the end it should be like full gravity negation, which would be the case here. That would happen. These 3 legs at the end get the same amount of work, and they get the most work. This one is like 45 degrees, and it gets a very small portion of that work. But altogether, they add up to 1. Now what happens if they should not... Well, in this case, it's 4. The value is over this higher than 3. Maybe that's what I say. Maybe I say... use the larger value between 3 and the sum of total work. Or I guess the higher between Yeah, the sum of total work and the legs divided by, or leg size times 2, or 0.5. But actually, I technically don't need to apply full anti-gravity, right? I shouldn't be applying full anti-gravity. I have 2 legs that apply anti-gravity on their own. These 3 legs would need to apply... Yeah, what do I think the total should be? Maybe it should be over the whole sum. I guess it should be of all grounded legs, right? If I have 2 legs that are already doing anti-gravity, then technically I don't need to apply. At least in this example, those 2 legs effectively already do anti-gravity. So at the very least, I could take off 1/3 of this value. At least 1/3. Yeah, how do I account for that then? I guess if I really think about it, it's always 6. Or the total work is always the number of grounded legs. Total work is the higher number between grounded legs and that minimum number of legs that I set to be able to apply full anti-gravity. So it'd be the higher number between, like, or the smaller number, sorry. No, wait. Yeah, the higher number between the number of grounded legs and the value that I want to be the necessary amount to have full anti-gravity. So if I had 2 legs on the ground, it would be the normal of all the legs, of all the grounded legs, which would just be 2 over 3. So at best, they would apply 2/3 anti-gravity to their attachment points. If I had 3, then it would be 3 grounded legs. If I had 4 grounded legs, they would all share the work proportionally. Okay. Um, what is gravity used for? First spring, but there's no spring on this one. First spring, there's no spring on this one. And then we're just adding it if we're slipping. All right, here's my idea. So I go back to each leg offset and I will just do an additional, so I calculate this and I'll do an additional change for anti-gravity. Well, this is, okay, so this is actually after gravity calculation. So I think what I do first is I probably go through each leg and I yeah, let me take this out. Update legs. I know each leg normal at this point. I can sum up the cosines with gravity, the absolute cosine with gravity, to get those values. And then I mean, what I could really do is I could calculate this in crawler leg, and then I can sum that up, and then I have the total, and then I run through it again the second time around here, where I would first of all modify my linear velocity according to some anti-gravity factor, and then I would read in my new ground velocity. Well, no, I think what I should do is every leg should apply anti-gravity first, and then I do spring on top of that. Yes. Okay. And I'll say instead of solve like offsets, I will do solve rotation, apply some body rotation to move. Actually, let me do it after springs. After all the springs. And a benefit to this is that I'll know if I did anti-gravity right, because the springs will already, the springs that will be doing anti-gravity will, that are aligned with gravity, will effectively provide that anti-gravity. So if I do this extra step wrong, which is only meant to apply on like totally lateral legs, horizontal legs, then I'll know I did it wrong because it'll like fly off in some weird way and it'll look strange. That's my hope, at least. If I do it wrong, it'll look obvious. I'll say solve leg gravity. I mean, I could actually mix it in. Maybe that's what I should do. I don't know which way makes sense. Because this will get the velocity post-gravity. Gravity applied to the whole mass. This will calculate current gravity. We apply the impulse. And then I check my normal. And I say, how much anti-gravity do I need to apply? Because it would be something that I didn't get from here. How much proportional am I applying? Yep. Yeah, I think this is probably the correct place to do it. So up here, instead of update legs, I'll calculate some total work value, which is going to be summing up the cosine angles, cosine thetas, the dot products. Grounded leg. Oh, this is weird. No, I need to calculate a total value. And that total value is going to be, I take the max between some value I set and yeah, I want to set some value here, which I'll just leave it at like 0.5. What should I say? It kind of fits in here. Where like a max force that each leg can apply. I think I'll say the damping won't be limited, but the spring force will be limited. I'm starting to lose it. I'm spacing out a little bit. I think I'm gonna name this something else. I'm gonna do like I'll just call it like parameters. And this will be like just body. Height offset, height spring stiffness, height spring damping, and then like, yeah, like what percentage of legs need to be grounded, assuming at least one leg needs to be grounded. And this is a percentage, right? Like, how do I demonstrate this as a percentage? There's like a certain string hint that exists for percentages. Dang. Is that gonna play? No. I can close that. All I know is export custom will get me there. I think it might be the case where if I just say percentage is the suffix, then it will... No, I don't think so. I feel like there is one where it will... Okay, whatever. It's whatever. Body. Leg. So this is like for anti-gravity. So this is how many legs are required. The minimum number of legs that would be required to firmly resist gravity. Leg. Shoot, like I don't know how to describe this. Percentage of total legs needed to fully actually not really. This is more like I'll say leg mass ratio. Percentage of total legs needed, or percentage of necessary necessary for maximum stabilize the body. Yeah, let me say lift the body. I'll say that. This kind of makes sense to me. Leg parameters. Why is it doing that? Yeah, it's just being stupid. Leg mass ratio. Percentage of total legs needed necessary to lift the body should not be higher than 0.5. Um, that, I think. This should probably be times 0.5 instead of a divide by 2. Doesn't really make any sense. Or else do I use leg size? Okay. Alright, that's it. Mass over grounded leg count, or mass over... External size times 1 minus that. So if this was... Oh yeah, this would be like leg size times 1 minus that, which would kind of be a really bad value, I think. So let me do this. That. And this will just be this. Okay. That's handled. If I ever put in 1, shouldn't break. This is just a crazy line. I can't believe I didn't fix that before, actually. This looks ridiculous. It does look just totally ridiculous. What am I thinking here? Whoops. Okay, this is just like kind of insane looking. I can't get over this. I'll leave it like that. Okay. I just need to clean that up. That was just looking... I mean, this also just looks insane because I have 3 parentheses here. Jeez. It's kind of nuts. It's a little bit better. I don't know. There's like there's just kind of no way to fix how this looks, I think. I could put the 0.5 first. That helps a little bit, maybe. I could do like a space. I guess that's a little bit better. That one looks a little bit better. All right. That just really bothered me once I actually looked at that a second time. I'd rather have more parentheses at the end than like 3 parentheses at the start, because that's like immediately I get to 3 parentheses and I'm like, what is happening? Maybe I start with this. That's better, right? .5 times ground point plus this. Right, the halfway point. I don't know, that's dense. I'm gonna leave it. I don't. The only way I could improve this more is by making variables, additional variables for these, like say midway points. I'll do it. At least now I can take off a parenthesis. This is better. Now it's obvious, right? Oh, this is a midpoint, you know, halfway between these two. And I get the local velocity, and I say relative ground velocity is this one minus like ground velocity. Right. Okay, a little bit better. Oh yeah, this is the problem. I do stuff like that, and then I forget what I'm doing. All right, so in here, I can sum up some like total groundwork. So I could say like a variable named that, perhaps. Okay. Gravity work total will be, I will be adding, yeah, I guess 1 minus the absolute value of ground normal dot a gravity direction. I need a gravity direction. Do I have to calculate this dot product one time, or do I need to keep calculating it? Well, I think probably I actually calculate this within legs, and then I can read it from legs. Like I do the ground offset. No. Nope. I'll just... No, because I do... Okay, I do need it again. I will need it again. Because I'll be doing this value over some total value for its proportion of work to be doing. Which is between the grounded legs yeah, what if it's like I have 3 legs planted and they all need to do like 0.1%. Yeah, it'd just be like 0.1 over, let's say 0.1%, like 10% or something. The cosine is the percentage of gravity it needs to account for. Or 1 minus the absolute. Let me do ground absolute gravity. Start with an infinite. I'll find out where that ground offset is set. And then I can do... Yeah, it's more just that I have to calculate the direction of gravity every time, which kind of sucks. Man, I do have to account for desired gravity now. I don't know why I would change this, though. Maybe I should just take this off. I don't know. I'll leave it for now, though I don't really like it. I don't know if I'm going to use that. I guess it's fine to have it. Oh, it's a bit annoying. Yeah, I need the gravity direction before I go here. Okay. That should be gravity. Alright, so now this is calculated before any legs update. So initial leg can do ground absolute gravity. I don't know why it refuses to do this. This is really annoying. Type the whole dang thing. Because it's just being stupid. And that should be that. One minus this. Okay. I don't know, maybe this should just stay 0? This is like how much gravity work it wants to do, so I guess it probably makes more sense to just leave it at 0. Instead of infinity. I'm still trying to think here. Yeah, this one's okay. Just right. Yeah, what did I say here? It should be total work would be the larger value between the number of grounded legs and total work. Or is it the max between legs times 0.5? No, because if I have 6 grounded legs, then I would want to say, all right, well, total work should be, you know, I need to account for the fact that these 2 legs are technically grounded and they should be doing nothing. Like, this shouldn't be 1, right? This should be no greater than 2/3, I guess, right? Or no greater than 1/3, because 1/3 of the body's mass is handled by these two legs, right? 1/3 of gravity's effect is negated by these two legs. So this value shouldn't be higher than 0.6 repeating, right? It shouldn't be higher than 2/3. And it is. So what does that mean? So that would mean if total worker was over 6, then this could be this is 1/6, this is 2/6. So if these were all zeros, then this would be 4/6 every time. But then if there are let's say there's 4 legs in contact with the ground and one of them is 1. So the result should be no higher than 3/4. So yeah, it is just at least in this case, it looks like it's going to be the max. The larger value between total work and legs, which I guess this means it would just always be over 6 because the most a leg can apply is 1. I could think of that. I could think of each individual leg as working. But it needs to be the case that if I have 3 legs on the ground, let's say I have 2 legs on the ground, what then? It should be at 3, right? So I think should it just be the smaller value between the number of legs and half the number of legs? So why do I need total work then? I think perhaps what I have to do is I have to calculate this value so I get their shared work. And then I would go through and now that I have their relative share between themselves, I would say multiply this by 2/3, I guess, or whatever number of legs are missing to be fully effective. Yeah, but I need this to get their like proper share, I think. Can I skip that though? I feel like I wonder if I could just skip that step if it's guaranteed to keep giving me the same result. So instead of doing shared work, I could then go through and I could say I'll just call it factor, and it'll be the smaller value between 1 and legs dot len. I think size is one of them, or is it like count? What is it? Is size a thing? I scrolled past it. Oh, the help disappears. Right, okay. I'll say 6 just because that's I know that's how much it should be. Then I multiply by factor. Okay. Jeez, I wish there was like an easier way to do this. Alright, so let's say I only have two legs on the ground. And one of them is fully like this. That wasn't right. I mean, I guess overall, I would have... No, because one leg should max out at like a third. Oh, this is weird. What I would expect to see is a 0. And if I know that one leg can do a maximum of a third, then I would say 0 and a third in this case. So what was my mistake? I know that total work came out to 1. So this could be used to give me my 1/3 value. Maybe this is where total work would actually be limited. So total work needs to be at least 3, or whatever total work is. So I could try that. So it would give me the right value if I had more than 3 legs on the ground. Which the only way to get a value higher than 3 would be to have at least 3 legs on the ground. I could compute like a total gravity effect, which would just be to sum up the absolute values and then or sum up 1 minus the absolute values. So if the legs output 1 if they should be doing maximum gravity effect, and they output 0 if they shouldn't be doing any gravity effect. I don't know, I guess this does mean like the total gravity work that I would like to do is what this means. for that leg. But it is the case that, say, if I have... So this might read the correct value. Okay, no, it doesn't. What should be read here is that would give me 0.3. Because the first two legs are handling effectively 2/3 on their own, and then the last leg needs to handle that last third. That's what I would expect to see. I think I might be toast. I think I'm toast. Total work would be 1. Maybe total work is kind of a different value than I think it is. Because if this was just I mean, yeah, I mean, if I really think about it, it would just be total work. The smaller value... Wait, no. Over... No, it would be legs and that. And it would be the max. So that one gives me a third, which is what I would want to see. If I take a leg out, then I'd want to see still a third. Now if I were to add 2 legs, what I expect to see here. What would I expect to see here? I would expect to see that that 3/4 of my gravity is handled, so I'd want to see 0.25. And that is what I see. So what if I did this and this? I'd want to see 0.25 for both of these. And I do. If I would take this out, I'd want to see 1/3 for both of these. If I were to make this 0.5, what would I expect to see? I guess this means I'll have to do half the amount of gravity, which means I guess I'd want to see a 1/6 on both of these. That seems right to me. That's a 1/6. Here I would expect to see a 1/6 as well. If I had 5, 1, 2, 3, 4, 5, and then a 6th leg, I want to see 1/6. And then if it was half of this, it'd be half of a 6th. I can't remember off the top of my head what that looks like. Is it like 018 something? Or 08? A bunch of 8s? 83. Yeah, that's what I had in mind. Is that the formula then? So I don't need to know total work at all. I don't need to know total work. Alright, what if I have one leg? I mean, yeah, it would just be doing 0. If I had one leg with 0, it would be doing a 1/3. If I had 2 legs with 0, it'd be doing a 1/3. 3 legs with 0, a 1/3 on all of them. What if this one only had half? I'd want to see a 1/3, a 1/3, and a 1/6. I think that makes sense. Okay. Seems right to me. I would think of a 45-degree angle. Like half. I would do half the gravity, but I know that the actual cosine of that should be like point. It's not quite the same, right? Is that right? Should I be doing like a linear thing? Where I grab the angle and then I divide it by pi? Or pi over 2? Why are circles weird like that? That's like strange to me. Because I feel like if I had a 45-degree angle leg, that means half of its force is going opposing gravity. That's not what it would be, right? Math, I think. I can say math cosine of it's like 0.7 something. Yeah. Which is strange. That doesn't seem right. It seems like it should be more of some kind of a linear thing. I mean, maybe that's correct. Maybe that is correct. I'm trying to think of that because I do have to think about lengths, like a unit circle, you know. I feel like this might turn out wrong. Yeah, it's going to be a little incorrect. Oh man, let me look at this. I'm not sure. Because yeah, it would have to be a 60-degree angle before I apply half of gravity's reduction. Or half anti-gravity. But I feel like it should be a straight line almost. Like 45 degrees is when I need to do half gravity. And then over 45 degrees, I feel like I'm right here. I feel like I wouldn't be using that. Yeah, if you were to, I feel like if you were to draw a box around this and then extend this line out to hit that box, or I guess not even just that, it would just be like a cut, a line, a straight line here to here, and then where that intersects is where you would do it. So in that case, this would intersect at, 0.5. But how can I do that? So out of it. Alright, I think I gotta call it there. I'm actually just so out of it right now. But I feel like I might be right about that. Because in my mind, that's a linear case. If you're at 45 degrees, half of your work is resisting gravity and the other half is not. Like if you're at 1 degree, then I would expect 1/90 effectively to be necessary for anti-gravity. I'm gonna call it there for today. I'm like getting tired and spacing out. So, let me go and write down what I'm doing right now. So I'm, anti-gravity to be proportional to the normals of the ground spring force. Relative to the direction of gravity. So at 45 degrees, apply half anti-gravity to a leg. At 90 degrees, apply full anti-gravity to a leg. Yeah, I think this will have to be like a cosines instead. So I get the absolute value, and then a cosine that, and then divide by pi over 2, because it would be no more than 90 degrees away. So if you think about it on the unicircle, it would essentially be like this. As they're aligned, x is 1. As they get unaligned, it becomes 0, and then because absolute value, it bounces back. So it would be an angle between 0 and 90 degrees. I'm like spacing out right now. Okay. That's it. That's it. Thanks for watching. I'll be back tomorrow. Goodbye.